Alright, let me set the context for the video. Today we're building a prediction market from scratch. I don't know how many of you guys have been trading on, IPL matches, but unfortunately now the only way to gamble on them is through prediction markets like Polymarket, 𝗟𝗶 and Stake. In this video, we'll understand how these products work under the hood. They're a fairly generic product. Don't just apply to IPL markets, but apply to a bunch of markets like politics, elections, crypto, so on and so forth. So we'll understand how exactly a platform like this is built. Technically, both 𝗟𝗶 and Polymarket are decentralized, but we're not really building decentralized versions of it. If you want a one-to-one product, 𝗟𝗶H is a company from India that was building prediction markets until the ban happened 6 months ago. So you can think of this video as building something like 𝗟𝗶H from scratch, basically a place where people can come and trade on their opinions. Opinions can be things like who's going to win this Kings 11 Punjab, this IPL match. Sorry, Kings 11 Punjab. It's probably out, but you get the idea. Any opinion, who's going to win the next elections in India, who's going to win the next elections in the US, what will the Bitcoin price be in the next 5 hours, 10 hours, things like these. How do these prediction markets work under the hood? How are the order books that they have different from the order books that we see in traditional finance? And how this is a slightly different yet similar problem statement compared to a centralized exchange. What are the various architectures that exist for this? All the finance are needed to know something like this. The video is also sponsored by 𝗟𝗶H, so we'll be using them as our database provider and our auth provider today to build this complex project in 3 hours. Without any further ado, let's get right into it. Alright, hi everyone. Let's build a prediction market together. I don't know how many of you guys used to gamble or currently gamble on IPL, but there was a lot of, Dream11 action that was happening up until a few months ago. The government ended up banning Dream11, MPL, all of these applications, but the money / gambling just moved on chain. Now most of the people that gamble on IPL are either gambling on Polymarket, 𝗟𝗶, or similar prediction markets. So we'll understand, how do these prediction markets work under the hood? How can you make a prediction market yourself? A lot of these are decentralized. So how do you actually take money from people? You of course can't take money through bank accounts, 𝗟𝗶, because 𝗟𝗶 will not give you API keys for a business like this. So how exactly is money being moved? I don't know if you guys have friends, but a lot of people in college are now selling USDT because, gambling is still a thing and people still want to, gamble on things like these. And you can see the volumes are pretty solid. There's $2 million worth of volume over here. Probably not as big as it used to be on MPL, because this is also a slightly different product compared to MPL and Dream11. But long story short, this product lets you gamble on who's going to win. For example, this IPL, there's 38% probability that RCB wins, 36% that Gujarat wins, so on and so forth. So if I want right now, if I feel that RCB is going to win, I can actually put in, around $40. And if they do end up winning, I'll make $100. If they don't win, I will lose my $40. And as you can see, this is purely based on probability. 30% of, the people feel that RCB is going to win, and hence it's slightly expensive to buy RCB compared to Rajasthan Royals. If I feel like Rajasthan Royals is going to win, if I put in $13, I'll make $100 on RCB. But to make the same amount on, Rajasthan Royals, to make the same amount on RCB, I will have to put $40 or something like that. So you get the idea. The higher the probability of someone winning already, the more money I have to pay for $100. How does this happen under the hood? It happens based on an order book. For those of you who don't know, order books are a fairly common data structure used in finance. But the order books that are present on platforms like these, for example, on Polymarket or 𝗟𝗶, are slightly different than the order books that are present on platforms like this backpack. As you can see, this also looks like an order book, but it's changing constantly. And, there's a lot of action happening over here compared to the order book that you see over here. There's not a lot of movement here. There's not a lot of movement here. So we'll understand the differences between an order book like this and an order book like this. And then we'll understand how exactly is it that this probability is translating to how much money I have to spend to make $100. How do you build something like this from scratch? It will teach you things like, number one, what are order books? Number two, this new construct, prediction markets, which blew up recently. When I say recently, like the last 2 years, 𝗟𝗶 is now worth $20 billion. Polymarket, I think the last round was worth $12 billion. So it's a fairly new and upcoming market. And it doesn't just let you bet on IPL, it lets you bet on a lot of things. For example, it lets you bet on things like when will Bitcoin hit 150k US dollars, and there's 1% probability that it will be June 2026, and 8% probability that it will be December 2026. Things like these. We're probably going to focus on markets like IPL, but it really doesn't matter. Once the tech has been built, you can create hundreds of websites like these. Cool. With that, let's get into some mild finance jargon we need to know before we get into the architecture. Let's understand a little bit around what exactly happens when a new market is created over here. How exactly can people bet on things like these? And we'll start with a simpler example of a binary market where there are just two outcomes. Here there are more than two outcomes. It can be Gujarat, it can be Royal Challengers Bangalore, it can be Sunrisers Hyderabad. That's like a slightly more very slightly but slightly different problem statement compared to something like, wait for it, this. Will Russia enter Stinky by May 31? I don't even know what this means. Probably is another country that they're trying to enter. But will they enter Stinky or not? And there are just two options, either a yes or a no. These are binary markets, slightly simpler. We'll understand, the tech behind building this. And once you understand this, you can actually, extrapolate the same logic to markets that can have multiple outcomes. Without any further ado, let's understand, under the hood, what exactly is happening before we get into the architecture of building something like this. All right, let's understand the most difficult bit about prediction markets. The first thing that sort of confuses people as to how they work under the hood. I've taken a random market over here. Will a category 4 hurricane make a landfall in the US before 2027? Right now, there's like 35% chance. So if I put in $35, I make close to $100 if I select yes. But if I select no, then I have to put in around, $69 to make an equal amount. So right now, there is higher probability of a no, and hence it is more expensive to buy no. But what does it even mean when I say buying a yes or buying a no? And the best way you can look at it is, think of every market over here as a stock market. Think of every time you're buying a yes as you buying a stock whose value will eventually go either to 1 or to 0 based on if there is a hurricane here or not. So if I right now buy, let's say, is there a way to select amounts? Maybe not. Let's say I, put in $1. That basically means I am buying 2.78 shares of this specific market. And if it does end up happening that there is a hurricane, my 2.78 shares will be worth $2.78. But if it doesn't happen, my 2.78 shares will be worth 0. The same is true for no. If I select no and, let's say select $100, that means I'm buying 134.44 shares of this market. Technically 13444, but you get the idea. Let's just stick with 134.44. If I click on no here and put in $100, I'm basically getting to buy these many shares at an average price of 74 cents per share. Is that true? Yes, that is true, right? 74 cents per share. If you spend $100, you get close to 134 shares. If you multiply 134 by 74 cents, you get $100. So effectively doing this and clicking on buy no is basically the same as basically having 134.44 shares of yes on this market, which might eventually resolve to $1 per share, or $1 per share, or $0 per share based on if there is a hurricane or not. So effectively, it feels like you're just buying a lot of these stocks. You're buying a lot of no stocks if you feel no is what will happen. You're buying a lot of yes stocks if you feel yes is what is going to happen. There are certain restrictions or certain conditions that these stocks meet though. Condition number 1: every stock is between $0 and $1. In the real world, a Tesla stock can be worth $1,000, but all the shares that you buy in a prediction market will lie in this category. Either will be as low as 0.001 cents or as high as 0.999 or 9.99 cents. You get the idea. 0.99 cents. 2. If you have one share of yes and one share of no, it is a delta neutral position. If I have one share of yes, hurricane will happen, and no hurricane will happen, what is effectively happening is either the hurricane will happen eventually. So my yes share will become worth $1, no share will become $0. If it doesn't happen, my no share will become worth $1, my yes share will become worth $0. So if I hold both the stocks in equal amounts, it basically means I have a delta neutral strategy. It's equivalent to me not participating in the market. So you usually either buy a yes or buy a no. If you're buying both, you effectively have a delta neutral position. Point number 3, you almost always can't buy one yes plus one no for less than $1 at a specific timestamp. You will never be able to buy one yes and one no. ऐसा नहीं होगा कि I can put 0 point, for example, to buy one stock of this, I have to spend 0.36 cents if I want to buy one stock of yes. One stock of no will be available for at least 64 or more. If I go here, if I try to select 64, the average price is 66. So I will at least have to buy 66 cents worth of it, which basically tells you can never buy. Abhi ke liye, if I want to buy one yes and one no, I have to spend 66 cents plus 34 cents or 36 cents, whatever it was, which leads to, a sum of $1.02. So that tells you, of course, you can't buy one yes and one no for less than $1. If that was true, then you would just buy the yes and the no for less than $1. And eventually one of them is going up to $1, the other one is going down to $0. So you're going to make a free profit of sorts, which is, of course, not possible. These are a few conditions that come on these, call them stocks. And if you look at this thing over here, the order book, it is basically a bunch of people that are willing to buy a yes stock for 34 cents a stock, sell a yes stock for 36 cents a stock. So if someone already has a yes stock, is sitting over here कि यार मैं एक stock अपना 36 cent पे बेचने को ready हूँ, I'm ready to sell one stock at 36 cents, and these are the total stocks that I'm willing to sell at this price. It could be one person, it could be 20 people that are sitting over here. The total quantity is 29.74. So if I actually try to buy yes over here, up until 29.74, shares. So that's like $10.71. I'm going to just get matched with this person. If I say I'm willing to spend 10.71 cents to buy a yes share, what is happening is I'm buying it from whoever is sitting on this order book willing to sell this. However, if I select 11 point, $71, then I am buying a few from this guy, basically $10 worth of stocks from this guy and $1 worth of stock from this guy. If I increase this to $100, notice my average price is now $39. So I'm buying some from here, some from here, some from here, and some from here. I'm basically eating the full order book like this. If I end up being right, I'll make $254. But I bought some for 36 cents, some for 37, some for 38, and some for 39. That is what this order book represents. And it is no different from an order book on a platform like Backpack or Binance or Coinbase. Any finance platform that you go to, even Zerodha, and if you look at a specific, market, this means the same thing. If I right now try to buy Bitcoin, I can buy 0.36678 quantity at this price. But if I want to buy a lot of quantity, then some I'll get at this price, some I'll get a little bit more, some I'll get it a little bit more, some I'll get a little bit more, so on and so forth. So these are people willing to sell Bitcoin. These are people willing to buy Bitcoin. If in the future I already have Bitcoin and I want to sell it, this is what someone is willing to buy it at. So if I want to sell, 0.54 Solana or 0. Whatever the quantity is over here, that much BTC, sorry, not Solana, I can sell it at this price. But if I want to sell a lot of it, then I'll sell some at this price, some at a little lesser, some at a little lesser, some at a little lesser, so on and so forth. So order books, a construct very constantly used, in finance, sort of ended up making prediction markets as a construct. Only thing is it's a little different because it carries conditions like these. Okay, let's read through this once. Every prediction market. So this is one prediction market, but there are, hundreds of different markets that are active on Polymarket. Every prediction market lets users buy a share of either yes or no on that market. So if you're coming over here, you can buy a share of yes, buy a share of no. If you already have yes shares, sell a share of yes, sell a share of no. Eventually, one share, let's say the yes share, is going to resolve to $1. the other share is going to resolve to $0. Until the event has ended, you can buy a yes stock, buy no share for less than $1 only. ऐसा कभी नहीं होगा. Even the most expensive one is available at 99 cents. Of course, you will never buy it at $1 because that's the maximum value it can get anyways. You'll either get it at 99 cents, 98 cents, preferably at much lower, so that by the end, if it does reach $1, you end up making some profits. Until the event has ended, you can buy yes or no. You can also sell yes and no's beech mein for less than $1 and hope to win. The question before we get into this section that you should have in your head at this point is कि Harkirat, this market was created, on let's say December 31st, 2026. So someone came and created this market. Now, when this market was created for the first time, I repeat, when this market was created for the first time, no one has any yes shares of this market. Do you agree? तो नई नई मार्केट बनी है, फ्रेश मार्केट बनी है. No one has any yes shares. No one has any no shares. तो Harkirat, if I come on this platform and click on I want to buy yes, who am I buying it from? Who is sitting on this order book? No one has any yes shares. This is a fresh market. तो ये बैठा कौन है यहाँ पे? Who is sitting over here that is selling? There are no yes shares that have been issued. It's a fresh market. Is this Polymarket that is sitting over here? Who is sitting over here on a fresh market जो नई नई बनी है? चलो over time, people bought somehow, people bought yeses and people bought nos. But immediately after the market was created, what exactly happened? And shouldn't this order book be empty, Harkirat? Because the market has just been created. And the answer is yes. As soon as an order book is created, the order book, of course, is empty. As soon as the market is created, there is no one willing to sell yes. There might be people willing to buy yes, but there's no one willing to sell yes because no one even owns yes right now. The same is true for no. No one really owns the no stock, and hence there can't be someone who's sitting over here initially. People can only be sitting over here. So the question comes, how does the very first share get issued? How does someone get a yes share in the first place so that they can eventually sell it if they want over here? The same is true for no shares. Think about it. How exactly does it happen in traditional finance? If I'm looking at let's say this Solana spot or BTC spot market on Binance, on Coinbase, on CoinDCX, or on Backpack, how exactly are people sitting over here? And the answer is they've bought Bitcoin from somewhere else, right? There's a lot of Bitcoin they have bought, deposited on Backpack, and that is what causes this order book to appear. I'm connected to a VPN, so we don't see it right now. We see it right now. So these are like real Bitcoin people have either, deposited from their decentralized Bitcoin wallet over here, and then they're trying to sell it over here. This is no available stock on chain. This is not Bitcoin or Solana or Axis Bank or Tata Bank, Tata stock that people already have. So how does the first stock get issued? The answer lies in this part. Prediction markets support 4 operations. Prediction markets support 4 operations. Split, merge, bid, ask, or split, merge, buy and sell. Buy and sell, we probably understand. If I open a market, I can come and buy a yes stock. If I'm feeling strongly that there will be a hurricane, I would want to buy a yes stock. I would want to put $100 over here because I know hurricane aa jayega. My $100 will become $250. If I feel the answer is no, I would want to put $100 so that my $100 become $134. That is buy and sell. Question is, what are the other 2 things? Split and merge. Try to think about it for like a minute. Pause the video. How do you think the initial set of stocks are created? The answer is, when the market is created, there are market makers or people who want to make some profit off of, just being on the sidelines, by which I mean, they don't want to really chase P&L based on iska result kya hai. They don't want to make money based on what the result is. They just want to make money by making the market. Do we understand the statement market makers? Do we understand Jane Street, Citadel, HFTs, Alpha Grep, Quad Eye? What do they do? A lot of them are market makers. A lot of them make this order book. So you and I simply come here and buy. We eat from the order book. We take from the order book. But these guys make the order book. These guys will come. The first thing they will do is they will select split over here. They'll be like, थोड़े नए स्टॉक्स बनाते हैं इसके. Let's create fresh stocks for this market. This is a new market. There are no stocks in this market yet. So let's create 10 yes and 10 no stocks. Split a USD share into a share of yes and a share of no. You can do this to save cost. Forget the second statement for now, but you get the idea. I can spend $10 and click on split shares. And now notice I have 10 yes shares, 10 no shares. I also have less $10 in my portfolio. I spent $10 to get 10 shares of yes and 10 shares of no. This is how the very first time yes and no shares are created. Now that these shares are issued, I can actually sit on the order book. I can say, hey, I want to sell 10 shares at a, if I select limit over here, I want to place a limit order. I want to sell 10 shares at a price of, let's say, 70. And I want to sell my 10 shares at a price of, sorry. Oh, that was wrong. I want to sell my 10 shares at a price of 38. ये हो जाएगा. Oh, it is restricted in my region again. It says I can't trade because this market is restricted in my region, which is weird because they let me split. They should let me trade also, but it's fine. What would have happened is I now own 10 shares of yes and 10 shares of no. And if this was an empty market, right, if there was no one sitting on this order book, I could actually be like, yeah, I'll sell my yes share for 55 cents. I will sell my no share for 55 cents. If there was no other market maker, कोई और बैठा ही नहीं है order book पे, this is like a fresh market, a lot of people want to buy, but no one's selling. What I would do is I would split 10 shares and I would sit here on the order book. I'll sell a no share for 55 cents. I will sell a yes share for 55 cents. People don't have any other option. People just buy it from me. And then for every share that I split for $1, I will make $1.05. Hopefully that was clear. I spend $10 to get 10 yes and 10 no. I will start to sit on the order book to sell a yes for, let's say, 36 cents and a no for 66 cents. If people buy my yes and my no stock, I will make 36 plus 66. That's 1.02. So that's like, a 2% kicker on my original $10 investment. That's how the initial set of stocks are made. A split functionality lets you convert a USDC into two stocks. It is a delta neutral position, so nothing really changes. If you feel like you don't want to sit on the book, then you can merge as well. If I merge 10 shares, what happens? My yes and my no get merged into $10. Just the opposite of split. Split lets you convert USDC or US dollars into a yes and a no stock. Merge lets you merge one yes and one no into $1, which is a delta neutral position either way. So what is happening effectively is, number one, market is created, which is the first thing that happens. Number two, market makers come and split their USDC. So basically, let's say, market maker 1 puts $100, creates 100 yes and 100 no. Market maker 2 puts $200, creates 200 yes and 200 no. By the end, how much US dollar does Polymarket hold on this market? It holds $100 for the first guy, 200 for the second guy. So it holds $300 right now. And how many shares have been issued in the market? 100 yes, 100 no, 200 yes and 200 no. So 300 total. Now market makers are sitting and these 300 shares of yes and no get distributed amongst thousands of people. So 300 yes and 300 no. People are trading, they're basically gambling with each other. And iske baad, all the money transfer is happening between people. If I am sitting on the order book and someone gets my order, they give me money, I return them the stock. It's not like the platform comes in the middle. The platform's job is only to take $100, split them into 100 yes and no, take 200, split them into 200 yes and no, and then let people trade on the order book. Eventually, 300 yes, 300 no are being, distributed amongst lot of people. Then eventually, one market wins, right? Or, let's say yes wins. So now what happens? There are 300 yes in the market, 300 no. Whoever has yes gets $1 per share. Whoever has no gets $0 per share. These $300 that Polymarket had, it disperses it to, whoever holds yeses by the end. Whoever holds no now is gone. But notice the amount of USDC here is equal to the amount of yes in the market and equal to the amount of no in the market. So Polymarket always has your money. The way to create shares is to give them US dollar, and eventually one of the share is going to win. So effectively what you get back from Polymarket is again the original dollar for that specific share, the original dollar that was used to split that USDC. That US dollar was split into two stocks. One of those stocks won, and that US dollar comes back to the winner. That's it. So they always have your money, and it's not like they can run away with your money. Every time the stock is created, they take the US dollar for it. Hopefully we understand split, merge, buy and sell. Market makers come, split USDC into stocks, sit on the order book, which means they create limit orders. Here I want to sell my yes stock for 66 cents, these many yes stocks. I want to sell my no stocks for these many cents, or I want to buy, no stocks for these many cents. That's the job of an order book. If you look at any traditional finance or crypto market as well, the only thing that market makers do is they just sit on either side of the book. They're just willing to buy BTC at slightly lesser, sell BTC at slightly higher. They make the spread in the middle. That's exactly what they do here as well, which is why this problem statement is very close to building an exchange or an order book, because effectively it's the same thing. The only good thing or the only difference is this is slightly less complicated because it only has specific price points at which you can place orders. So that's like 1, 2, 3, 4 up until 100. Same is true over here. It's not like you can place an order at 1.11 or 1.22. That makes things a little simpler. Number two, not a lot of activity is happening compared to if you saw Backpack Exchange. A lot of activity was happening on this order book. So the functional requirements are slightly lesser, and hence you can use simpler architectures to build something like this. Hopefully you understand all the finance jargon before we proceed into the next section, which is going to be the architecture of building something like this. Specifically, you need to understand these 4 things. You also probably should understand by now what are limit versus market orders. And of course, you should understand, what the order book is and both the sides of the order book. One side is called a bid. The other side is called the ask. Everything that is sitting over here are people bidding. Okay, I'm willing to spend this much to buy. I'm willing to spend this much to buy. You might ask, Harkirat, why is he sitting over here? Why does he not split the token? And the answer is, if he splits, he gets both yes and no. He only wants to buy yes. When I come on this market, if a newbie comes on this market, he doesn't understand what split is. He just wants to buy the yes token. So he'll just buy whatever is the best price, uspe, which is 36 cents right now. Of course, sometimes it's better for the person to split their $10 US into a yes and a no and then sell the no rather than buying the yes. They're both the same things. You can come here and buy a yes, or you can split $1 and then sell the no, which is the same as buying a yes, because in the end you're left with a yes. That is exactly what this is said also, right? If you look at split, what did it say? You can do this to save costs by getting both and just selling the other side. You can either buy yes or buy both and sell no. It is the same thing, and sometimes you can save money by doing this. Cool. Given you understand this, and this should be very easy to understand if you have already done finance and order books. If not, this might be a little tricky. Let me ask you a curveball question. How do you think this probability that it shows, this graph that it shows, is decided? The answer is, it is decided based on what was the last price at which things were traded. Right now, the last price is $36. If I currently buy, let's say a market order of $100, my average price will be 39, which means I will eat this order, this order, this order, and this order. You will see this go up to $39. Let me see if I can buy. I did buy. Did I? Seems like it. No, again, same thing. It says you can't buy. It's a weird limbo right now. I somehow still have yes shares. I don't know how. Even though when I merged, they should have gone away. It's fine though. I can slightly place orders, not place orders as well as something weird happening because of the region I'm in. I'm in no region. I'm just connected to a VPN. And hence it's not letting me place orders, but you get the idea. If I did place that order, I would have eaten this, and this. The last traded price would have become 39, and this graph would have gone up to $39. So this graph simply represents at this specific point what was the last traded price, and that's what leads to a longer time series graph. Cool. Given we understand all of this jargon, and given hopefully you understand this, let's get into the architecture of building something like this. It's not too difficult to build because, as I said, there's not a lot of activity over here. So order books don't change as often here, and hence you don't have to do a lot of optimizations you have to do for order books like these. So we'll understand a simpler architecture which will suffice to build a prediction market order book. That same architecture will not suffice to build something like this, but should be good enough over here. With that, let's get into the architecture of building something like this. All right, let's get into the architecture of building something like this. There'll be a few moving parts, a few microservices. So let's talk about all of them. Primarily, Polymarket and 𝗟𝗶 are meant for people who on-ramp and off-ramp via crypto, which means they have crypto, people have crypto USDT in their, specific wallets. For example, I have, Phantom over here or Backpack over here where I have, whatever, let's say. $599 USDC. I can deposit this $599 USDC into Polymarket, and then I will see it as my balance over here, and then that balance I can use to trade. Eventually, if I make a profit or a loss, I can always withdraw it back into my decentralized wallet. I can always off-ramp it back to INR, US dollar, whatever. That's how most people are trading. As I've mentioned, you probably can't get payment gateway API keys for something like this because still a little gray, mostly not even gray, like say legal to build something like this in India. So you can build this for the world from India if you want, but primarily you probably don't want to target Indian customers. Architecture wise, even though most of these websites support login with Google, email, etc., I am not too inclined to build that. I think we've built that a few times on many videos on this channel. So what we're going to do is support login via wallets. So that means, wallets like MetaMask, Phantom, on specifically we'll stick to the Solana blockchain, but you can sort of make this work for Ethereum, other blockchains as well. On our website, when people come, for example, if I log out over here, when people come to login, they will only see the options of Phantom, Backpack, MetaMask. They will not see a login with Google and email address. This is good and bad for multiple reasons, but mostly good because, for Polymarket, if you log in via Google, you still get a decentralized wallet, which, private key management gets very tricky, and hence we're going to stick with the user having their own Phantom wallets. Anyways, we expect them to on-ramp via crypto, and that way also we get a full-fledged product without depending on a payment gateway to, provide us an API. So the question is, how do you log in with wallets? That's one new thing we learned today. In the end, we'll have a front end. And whenever user come over here, they will log in via something like Phantom. And when they click on this button, what we're going to do is make them sign a message using their private key from, Backpack, Phantom, wherever. And once they do sign a message using their private key, they are going to send that signed message to our backend, through which we will issue a JWT to them, and then they can keep sending us a bunch of future requests on if they want to buy, if they want to trade, so on and so forth. So the only difference from a more traditional system that you might have seen is that we don't allow login via email, we don't login via Google, we allow login via Phantom. And since we're using Supabase today, Supabase has very nice auth API for doing this, so it shouldn't be too many lines of code for us. Cool. Login, auth, totally done via crypto. And once the user has done that, the user can basically interact with the blockchain to send USDC to one of our wallets. So they'll be sending, we'll have a publicly listed, Solana address that they can send, let's say, $599 USDC to. So once I sign up on this website, I have $599 USDC here. I can send this $599 USDC to a wallet, and then the owners of this website, which is us in this case, know okay, this address is associated to Harkirat, and hence we will increase their database balance to $599. So effectively, users are going to send us their crypto, and our job is whenever we receive crypto from an address, we find the associated account, and we credit that user's account with whatever user ID, and then their wallet address, and then lastly the amount of fiat or USDC that they have, which in this case, user ID 1, wallet address would be my wallet address, and now I will have $599 USDC as a centralized balance in this wallet. In the future, I'm also allowed to withdraw. So whenever the user issues a withdrawal, we will decrease this amount to zero, and we will just send them their 599 USDC or whatever they have left in their wallet back. That's step one. Logging in with Phantom and allowing users to on-ramp, which basically involves them interacting with Solana. But we have to have a service running. Let's call it the deposit service, whose job is to constantly index the Solana blockchain, which means constantly listen to all incoming transactions to our address. And based on that address, whenever there is a new deposit, figure out who that user is and increase this balance. So that whenever you have deposits and withdrawals, which is common everywhere in a platform like this also, once you log in, you're allowed to deposit money. The same is true over here. If I log in, I'm allowed to deposit USDC. Our platform will support the same thing. But whenever you allow deposits via crypto, since users don't directly interact with your backend, they only interact with the blockchain. It's your job to constantly listen to the blockchain for updates. And if there is ever an update on a specific wallet address, in our case, our wallet address, we need to ensure we increase the user's database amount to a certain number. That's all the complexity we need just for logging in and on-ramping a backend, a front end. The Solana blockchain is not something we have to maintain. User can directly interact with it, or the Ethereum blockchain in the future, whatever blockchain the user wants to deposit money on, and of course the database. Once the user is logged in, they are now allowed to, using their JWT, place a bunch of orders. That includes things like, I want to buy, the yes token on a specific market ID. They can send us orders like these. And now it is our job to, again, interact with the database. So the database will, let's say, have, to quick things off, two tables: a users table, which will look something like this. How much USDC does this user have? And maybe, actually that's good enough. How much USDC does the user have? So that's like the users table. Another table, which I'll call the markets table, which has, all the markets that we currently support. That would basically look something like, let me just delete that, something like this: an ID, and a title, a description, and an image if need be, but that's good enough. This could be, will there be a hurricane, and you get the idea. Description will be slightly longer, and then maybe an image associated with it. This entry will be made by admins. So whenever there is a new market, and they'll have a bunch of fields actually. Finished, and if it is finished, who was the winner? If the yes side wins, the no side wins, so on and so forth. It might get more complex. We'll do specific database design soon enough, but I think this much should be good enough. A users table, a markets table, and then a positions table, or positions table is fine, I guess, which basically stores which user has how much yes token of which market, which user has how much no tokens of which market. So it might happen that user ID 1 has market ID 1's no token, and how much do they have? So user ID 1, that's this person right here, on market ID 1 might have the no token with 10 quantity, so on and so forth. All the positions of the users, basically, if you remember the thing that you are seeing over here when I place an order, will be stored in the positions table. And I think lastly, what else do we need? We need another table, which is a little controversial as to should it be in the database or should it be somewhere else, which is the order books table. Why is it controversial is something I can get into eventually, but long story short, you generally avoid putting order books in a database. For a use case like this, it might make a little bit sense because number one, order books are limited in size, which means, they only have, a few orders, 100 bins in total, right? So it's like everything from here to here is like 100 entries. So you can dump a very big JSON blob here in the database, even though that's not done in traditional finance over here for multiple reasons. In our case, we can start with this to keep our our whole architecture simple. Architectures can get much more complex if you want to. I mean, I can quickly show you if you want how an order book should actually be stored in the database. And it doesn't look pretty, and it's like a lot of things that talk to each other. Let me quickly show you. It'll basically look something like this, which, as you can see, it's like a lot of microservices. This makes sense for a trading app, might make sense for a prediction market, but to keep things simple, and for a prediction market, actually, this might just be a little too much. And hence, I think we'll start off with this architecture and see where we go. But for now, all the order books for every market, so, market ID, and then, side. So it's like a buy or a sell side, on the yes or the no side, and then the full order book. So for market ID 1, for side, yes, the order book looks like this. So this basically will contain all the bids and the asks, an array of bids and an array of asks. And then for the same market, of course, there'll be a no order book that will again contain, all the bids and all the asks. This can actually be a little simpler, but we'll just stick with this for now. So the current order book, whatever appears, over here is a very big JSON dump that we have in our database, like this. Are there better architectures? There are. Only thing is they look something like, wait for it. Something like this, which, as you can see, there are like a lot of services, and the only purpose that this serves is that it makes the order book very fast, by which I mean you can place a lot of orders quickly, you can get a lot of orders quickly. In our case, as you saw, the order book barely moves for most markets. It's very different from something like this, where it is moving, so quickly, and hence we don't have to optimize for an architecture like this. A simple architecture might work. So, as people place a buy order, okay, hey, I want to buy, or a limit order, or a split order, or a merge order, our job is to get that specific order book from the database, do whatever operations we want, basically run the matching logic to ensure, if the user wants to buy certain stocks, they're removed from the order book. If the user wants to sit on the order book, they're allowed to sit on the order book. And then update, the user's positions. If they actually wanted to buy and were able to buy, we need to update this. Update the order book in case, certain changes happen. The book moved by a bit, you ended up eating the book, and maybe decrease the user's, amount. So there are like a lot of parts that we touch. We change the user's balance a bit, we change the user's positions a bit. The balance might decrease, the positions might increase, the positions might decrease, and the balance might increase, and of course the order book changes as well. This is totally fine. There's like nothing wrong in it. The big thing to keep in mind over here is whenever the user is buying, selling, market order, limit order, whenever they do something like this, we need to ensure we never let parallel transactions touch the same order book, for example, or parallel two transactions touch the user's balance parallelly. If that happens, the user might end up double spending. They might use this $599 on two different markets to place orders, which is something we want to avoid. There might be two people trying to eat the order book at the same time, and if we don't run the orders sequentially or serially, things will get bad. And I hope why you understand why they'll get bad, because both the people will try to eat the same order. So, the same person will be able to sell their stock twice to two people. And hence we need some, solid database level locking over here. This gets a little easier, believe it or not, in this architecture, because, over here, everything runs here sequentially. But in an architecture like this, we basically have a simple CRUD will not work. We have to ensure we're locking a bunch of rows whenever an order is placed. That's not true if a split happens. If a split happens, then, we only have to lock this and this. If a merge happens, you only have to lock this and this. But if the user is actually interacting with the order book, then 1, 2, 3, 3 rows sort of need to be logged at the same time. And when I say lock, I just mean another transaction shouldn't be allowed to touch these. The second transaction should remain blocked until these 3 get unlocked. That's the only complicated logic we'll see today. Other than that, one last thing we should support is like a withdrawal service. If the user wants to, withdraw after they've made their profits or losses, we should allow them to withdraw, which basically means we should decrease the US dollar balance over here, and we should just, send the money back to their wallet, whatever wallet they associated during their login. We can also allow them to, off-ramp or send money off to a different wallet, but basically similar challenges. Doesn't matter what the final wallet addresses. That's a high level architecture. I think that's all the services we'll need: a deposit service, a withdrawal service. This is just an RPC URL that we need to interact with the Solana blockchain. Superbase to create our database, Superbase to support login via Phantom. When the user comes, logs in via Phantom once, signs a message using their private key, sends it to the backend. We return them a JWT. In all future requests, they can use the JWT to buy a stock, sell a stock, merge, split, so on and so forth. So effectively, we're a centralized platform, and Polymarket, even though it feels like a centralized platform, isn't. It is mildly decentralized. It's built on top of another blockchain called Polygon, if you've heard of it. Ours is almost a purely centralized platform, by which I mean, all the orders are stored in our database. People can't track them publicly. People can track their own balances, their own orders, but they can't see everyone else's orders. But on Polymarket, you can just open a Polygon scanner and look at everything that's happening. So this is a centralized prediction market, which is closer to Probo. If you guys saw Probo or ever interacted with Probo, it's like a prediction market in India, but it's closed for business now because India sort of blocked opinion trading in the country. Cool. That covers the architecture. Not a lot of services. We'll start off with the backend and auth, I think, which are the more difficult, not the difficult bits, but whatever. The easiest things to start off with, probably. And then we'll make our way up with the deposit service, rest of the backend, and, a little bit of Solana jargon in the middle. With that, let's get into the first part. The first part should be just initializing the monorepo. So let's initialize a turbo repo next. Alrighty folks, let's get into the coding bit. Believe it or not, I'm recording this for the second time because the audio did not record for the first time. Hopefully it is this time. I'm going to start from scratch. I'm going to now again initialize a fresh turbo repo by running the command, wait for it, bunx create turbo @latest. I'm going to create it now in a new folder called prediction market YT maybe. I'm going to use bun as my runtime, and while this opens up, I'm going to open cursor and open this project again in cursor from scratch because I'm just doing this for the second time now. Prediction market YT. This is a fresh bun turbo repo, and I'm going to get rid of the two default front ends that come inside a turbo repo. For some reason, they're not for some reason. Vercel now owns turbo repo, and hence they're Next.js by default. But I am going to stick to a backend, which will be standard bun.js express, and front end, which is going to be a Vite based React front end. I'm going to call the folder front end. I'm going to select React as the framework, TypeScript as the language, and I don't really need to install the dependencies just yet. Now I have a front end and a back end. Front end is a default, React front end, and the back end, I'm going to quickly do a bun init to initialize an empty bun backend. So now I have a backend and a front end, and the first thing we have to do is figure out authentication because that's the first slightly tricky bit. Anyways, the first thing we'd do if we're building a backend as well. And this time, the authentication is a wallet-based login, and thankfully, Superbase does provide a sign-in with Web3 option where it lets you sign in into Web3 via Solana and Ethereum. We're just going to do Solana, but Ethereum should be very easy to switch on as well. So I'm going to go to the front end now and going to get rid of app.tsx, completely, return an empty div from here, which says, hi there, something like that. Just confirm it works. Bun install followed by bun dev, and if I go here, I do see hi there. I see a bunch of default CSS that I'll get rid of. And now when the user comes, the first thing we need to do is log in via Solana. So we basically need a button that says something like sign in with Solana, and when you click on this button, you need to pretty much pop up the user's Phantom wallet, backpack wallet, so that they can sign a message, send it to, in this case, Superbase, and Superbase is going to register them as a user and return us, their identity, a JWT token to authenticate them with our backend, things like these. So the next thing I'm going to do is basically go through the docs and figure out how to do that. The docs weren't too difficult. They involved calling superbase.auth.sign with web3 with the chain, which in our case is going to be Solana, and a statement that we want the user to sign, which could be something like, welcome to the prediction V2 market platform, something like that. Before that, let me create again a new fresh Superbase project. Again, I'm doing this the second time because, well, the first time the audio wasn't recording. Let me create a new organization. Let me call it Prediction Market V2 personal project. Free is fine. And let me create a fresh organization. For those of you who don't know Superbase, haven't used it in the past, it provides you a bunch of things. It's a database as a service, authentication as a service. It also has, a database that can directly connect from your client to your server. Let me create a random database URL, paste it over here, click on create project. Basically an open source version of Firebase was their initial pitch, and has been doing fairly well since then. Let me keep this backend database password handy because it will come in useful later. It will become useful later. And now this dashboard pretty much lets you to see everything. It lets you see your tables. When we eventually create a database and put a bunch of tables there, we can visualize them here. An SQL editor that lets you interact with your tables, a database section that lets you, again, visualize your tables, functions which are like, lambdas or cloud functions triggered, so on and so forth. Authentication is what we're focused on right now. They also provide storage if you want to store images, edge functions, so on and so forth. Real time is probably, as the name suggests, a bunch of real-time, infrastructure for things like, chat application. We are going to use their authentication firstly. So we're going to go to the sign-in/provider section and enable Web3 wallet. Specifically, I'm only going to enable, sign in with Solana for now. And I'm going to disable email because we're not going to allow people to sign in via their email. The only thing we allow our users to, let me just see if the audio is working. Yeah. Our users to, come and log in via their Web3 wallets. Cool. Next up, we need to now install their Superbase SDK. So let me go back to my front-end project. Let me do a one add at Superbase / something. Let me see what it is. React at Superbase / Superbase.js. Let me go back to Web3. And once that is installed, what we're going to do is import create client from Superbase.js, const Superbase equal to create client, and I'm going to give it 2 inputs. The 2 inputs are going to be, again, let me go back to their docs. The Superbase URL for our project and a publishable key, which is like a public key that we can, sort of share with on our front end, and it's fine to be shared. You can find both of them here. If you go to projects section, you'll find the publishable key in the API key section, the publishable key over here. Let me copy it and paste it. I think that's the second argument. Yeah. And the first argument is simply, if you look at it, if you look at the docs, it's your project ID .superbase.co. So I'm going to replace XYZ company with my project ID, which I can find over here. That should be good enough. Once I have this, Superbase variable, I can use it in this case to basically do authentication, sign in with Web3, was it? Yeah, sign in with Web3, and the inputs that it expects include, wait for it, for Solana, it is something like this, chain Solana, and whatever message you want the user to sign, which in our case it can be something like, I confirm I want to sign into prediction market V2, something like that. What this does is it makes the user sign a message in their, wallet, something like a phantom or a backpack. And once they sign the message, the signed message goes to Superbase. Superbase authenticates the user. It creates a new user on their side and then returns us, relevant information about the user. In this case, the only relevant information is their public key. So if I open my phantom, my public key, looks something like this, whatever this Solana public key is. There's no name information, there is no email information, and in most decentralized platforms like these, people sort of prefer that. They want to be anonymous, and hence that's all the information that we'll ever get. Cool. Once that is done, to get the user's identity, you usually create some sort of a context variable, but let me just create a top level effect for now, whose job is simply to populate a state variable called claims, which is just a commonly used term for everything, all the information about the user when they're logged in, which I can set by calling superbase.auth.getClaims. So if the user is already logged in, let's say they log in once and they refresh, if they are already logged in, this would return us their bunch of their information, things like their public key, when they logged in, what user ID we gave them in our database, so on and so forth. And we can also subscribe to any changes. So if they sign in the middle of their session, they open the website, navigate a bit, and then sign in, this subscription superbase.auth state change would ensure that if their authentication state changes, if they log in or log out, we update this global state variable. And always a good idea to get rid of subscriptions if the effect ever goes away / reruns. So this is like the most basic auth setup you will see in most Firebase websites, also in most Superbase websites, also any website that lets you basically do authentication without having a backend in the middle. Right now we don't have a backend, we haven't even written a single line of code in our backend, yet we're able to do authentication. A lot of platforms provide that, so does Superbase, and in most of these platforms you will see a top level effect like this. You would probably put it out as a separate hook. Let me actually do that. So let me go to front end, create a new folder called hooks, and create like a use claims or use user.ts hook, export function, use user, whose job is to basically do everything we did over here. That's like a little too much. And then we probably should have a use Superbase hook as well, so that we don't keep reinitializing this variable. I'm not doing it yet, but probably should. And basically everything from here. And we should just return, just claims is fine, I guess. We'll probably make this a little better, but const claims equal to use claims. Sorry, use user. Why do I not see it here? Import use user from dot. Oh, hooks should be inside the source folder, my bad. / hooks / use user. And now, yeah, there you go. That's why we need a use Superbase hook as well. So let me just quickly introduce that. Use superbase.ts. Export function use Superbase. Use fact const Superbase comma set Superbase equal to use state. Oh boy. Honestly, we can just do something like this. Don't even need the effect. And now I can just use this variable here. And then the same variable in our hook, which was the use user hook. Oh, we already have it here. Same thing here. Now, when the user clicks on this button, we should do something like this. And ideally, if claims already exists, if it doesn't exist is when we should let the user sign in. But if claims already exists, that means the user is already logged in, and hence we should show them a button that says log out. And when you click on this button, we should do something like, as you can guess, superbase.auth.logout. Oh, I don't see a logout button. Log.session. How do you log out a user? Let's see. Log out. Superbase.auth.sign out. There you go. Cool. Let's see if this works. Can I sign in, sign out? When I sign in, I should see a logout button. When I sign out, claims should become null again, because, you know, this specific on auth change hook would run, and get claims would basically return you something like null, and then you reset it, I think. Let's see if that happens or not. If I go back here, after I restart the front end, wait for it. If I go here, it says logout already, because, you know, if you don't remember, as I mentioned earlier, I already did this once. Logout does nothing though. That's not cool. I think this is all messed up because that was a different project. This is a different project. Let me host this on a separate port. Packages / front end, and let's do wheat -p3001 dash port maybe. Okay, let's try this now. Still says log out, which is weird. Do I have the condition incorrect? If not claims, then sign in. Use Superbase, and then use user. Initialize to null. Okay, let me just quickly log claims as well. And let's see. Claims null. Should look something like this, guys. My bad. There we go. Let me just keep this logged in. All right. When I come to this website, it says sign in with Solana. When I click on this, it pops my phantom up. It asks me to sign a message. When I sign this message, nothing happens. All right. This took like a decent bunch of time for me to figure out. Why does logging out still not work? It does. All right. I don't know, for some reason Phantom and Backpack both don't seem to be working for me when it comes to sign in with Solana. But what does work is Solflare, which is another wallet. You can select which wallet the user you want the user to pop out from. We can also give the user a bunch of options. For example, a bunch of buttons like if window.solflare exists, then give them a button that says sign in with Solflare with like a Solflare logo, and then if window.phantom exists, then give them an option to log in with Phantom, so on and so forth. So in my case, I have Solflare also, I have Phantom also, and hence it gives me both the buttons. For some reason right now only sign in with Solflare is working. If I try to do a sign in with the Phantom, it does pop out, in this case not even popping up this wallet adapter, or the wallet. It does throw an error over here, which is like a weird error. So try to debug this if it doesn't debug. The good thing is they also give you another way to do Solana wallets, which is, wait for it, using the Solana wallet adapter. So if you just go through this process, you can just use the Solana wallet adapter. It will make your life probably much easier. Yeah, that should do it, and it'll give you a bunch of hooks also that are super helpful. Or basically this use wallet hook will out of the box provide you what our use user hook sort of provides. So if this doesn't work for you, like it isn't for me, I mean, it just worked with Solflare. But for you, if it doesn't work, what you can do is use the other approach of using the wallet adapter. There are actually a bunch of benefits of using the wallet adapter. So not the worst thing to migrate this into something like this with the second set of docs here that use Solana wallet adapter. For now it works for me, so I'm just going to proceed. If I refresh this, I see an option that says sign in with Solflare. So our website only supports Solflare for now, and if I approve, I do log in, and I see a bunch of things over here, including some user metadata, specifically the public key of this specific user, what chain they selected on, what message they signed, so on and so forth. And now this user is actually very close to a Superbase user that's logged in via email and password, or logged in via Google, or logged in via Facebook. as we've talked in the past, the way Superbase or generally authentication works when you basically do something, use an external provider like Superbase, what happens is this is your front end. It never really talked to the backend in the process of signing up. In this case, the user signed a message, and that signed message basically reached the Superbase servers, and the Superbase servers sort of return you some information, store it in the local storage, and that way you see every time, even if I refresh, I'm still logged in over here. The problem is, if this front end needs to now talk to my backend, it needs to give me some sort of a token that I need to verify later from Superbase. And only if it is verified correctly do I know that this user is indeed who they're claiming to be. And hence the authentication process, even though it becomes slightly easier over here, it gets slightly tricky over here. So let's get into that next. Let's, once we've seen that, the login functionality is working as expected, the logout functionality is a little slow or broken, one of the two. I would call it slow, but still working as expected. So the next thing is, how does the front end send, authenticated requests to the backend, which in our case, we're going to have many of these, right? In our prediction market, we're going to have if you remember, 4, things, create order, or, basically buy endpoint, a sell endpoint, a split endpoint, and a merge endpoint. At least for the user, they'll have these 4 endpoints plus, the /balance endpoint that returns them their US dollar balance or USDC balance, their /positions endpoints that shows them all of their currently open positions, probably a /history endpoint that shows them all the buys and sells that they've done in the past. All of these are authenticated endpoints. We need to implement them. But we need to make sure all of them, are only accessible by the user. Other than these, we also need a bunch of, probably admin endpoints, or we can just, make direct entries in our database. So we don't really need like an admin exposed route. Either way, before we start to write all of these, endpoints, notice we don't need a sign in or a sign up endpoint. Why? Because all of that is handled by Superbase. We just need to somehow, from Superbase get some sort of a token. Once we have that token, forward it to the backend, and before anything reaches to these authenticated endpoints, we just need to go through a middleware whose job is simple. The token that you received from here, this token needs to be checked with Superbase to ensure that this user is indeed logged in, and if they are, is when the request gets forwarded to one of these routes, which of course talks to a database. Cool, a bunch of services to build next. Let's get into how do you fetch the token over here on the front end. How does it get extracted on the middleware, and how can we actually have 6 endpoints or 7 endpoints that are authenticated? Let's get into that next. Alrighty, let's get into the backend. Let's quickly initialize. We already have like a backend project that we initialized, if you remember. And now I'm going to create a very basic boilerplate of everything we need. So we already did a bun in it. A bun add express at types /express course. I think that's it for now. Import express from express. Const app equal to express app.use express.json app.use course. Then at types /course is also something we need to add, I think. Maybe not. Import course from course. And now let me quickly create all the endpoints. We wrote them, where is it? Here. So /by. Ideally there should be like a single endpoint, the /create order endpoint, but this is also fine. A buy, a sell, a split, a merge. A balance, positions, and history. Balance would be a get. Positions should also be a get. These are like the open positions that I have, and history is probably the closed, history of orders that I placed and then sold, and then P&L that I made on them. Cool, that sounds easy enough. The only thing is, all of these endpoints need to be authenticated. So let me add a middleware. Oopsie daisy, middleware that will do authentication for us in a separate file, and that's the meat of what we need to focus on right now. Let me create a middleware.ts file, export function middleware, which takes a rec, which is a request object from express, a res, which is a response object from express, and then a next, which is a next function, which is going to take a token from the header. So rec.headers.token, let's say, or it can be rec.headers.authorization, and then it can have two parts. It can look something like this, where space the token, or it can just be the token as such. Then comes the interesting bit. Given that the user sends us a token, we need to verify with Supabase, is this token valid or not. There are actually various ways of doing this. We can get some sort of a JWT, and we can also export a JWT secret from Supabase, and then just simply verify without logging in, or we can just talk to Supabase whenever the user hits our backend. Ideally, we don't want to talk to Supabase because every request will become very slow, because we have one more hop to go to Supabase. So ideally, we should export a JWT secret from here. Either is fine. We'll see which one we go with. Let's go to authentication. Let's see if there's it's easy to export a JWT secret. Don't see one at the top of my head here. Over here, I do see JWT keys here. This one is of this ECC type. There's also a, what is this? I forgot the full form, but another algorithm to hash JWTs. And then there is also legacy JWT, something that we have over here. Control the keys to sign JSON web tokens for your project. Okay. Seems like, oh, there's a key ID. How do I view key details? And there we go. Man, is that longer than I was hoping for. It has a few things in here. Discovery, URL key ID, and then the public keys, which is like a more complicated array. This is fine. This is actually better than a simple JWT secret. There's one over here. I don't know how it was created 7 hours ago and how it was changed. Then there are API keys, and then this is a publishable key. We don't need that. Secret key allow you to access your database and servers, functions. This is probably what we need. We can go down the other route as well. That's probably better. But let's try to use their secret key that we have over here. So let me put this inside the .env secret underscore key, or probably Supabase secret key, and use this for now. And if we need to change it, we'll change it. All right. Now comes the question of how do you initialize a Supabase client on the backend. So Supabase on backend get user, something like this. I mean, I'm okay reading this or this. This is almost exactly what we need. So I'm just going to defer to AI over here. This will be an async function, and as you can see, we await over here, which basically means this is going to be a little bit slower. Const Supabase equal to, let's bun add at Supabase slash, I think it was Supabase dash JS. Let's see if they don't have an import here. Okay, let's go back here. This is exactly what we need. The question is, how do you initialize the Supabase variable? Like, how do you pass in like a secret key? And I think it should be as simple as, let's see, it keeps scrolling up. Maybe not. I think I could be wrong. It should be as easy as doing create client with a Supabase URL, which will be the same as the front end. Use Supabase. So basically, this thing right here. Oh no, not this. This thing right here. And the secret over here is going to be process.env. Whatever we had in our env file, which is this. I think this might work, might not work as well. We'll confirm very soon. This is the admin key, which we're storing on our backend, and hence, I think we should be able to fetch, users details given a token. Let's just log it for now. Console.log, user, maybe something like this. Put this inside a try catch. And if things go bad, then simply let the user know that whatever they've sent is, incorrect. Rest.status 403.json message. Incorrect credentials. Cool, something like this. That should be fine. Let me also log error over here. And let's import this middleware in our index.ts. And let's just simply do a rest.json of whatever message hi over here for now. On our front end, let me try to send a request when you click on another button. So let me add another button. Click here to buy, whose job is, let me do a bun add Axios on the front end, whose job is simple. When you click on it, you do Axios dot posts, the backend URL, which in our case is localhost colon 3000/buy, with a bunch of headers. I think that will be the third argument here. Authorization, which would be that is the question. What would it be? It would probably be await supabase dot auth dot get token. Do we have an auth dot session? Auth dot session dot get token. Nope. Sorry. Get session. Get to session dot. Is there an access token here? There is an access token here. Boy, is it long. That before. Wait, this is a thing. Yeah, that's like a little longer. So what we want is something like this, actually. Cool. And cool. Let's do it. Send a post request to /buy with these headers. And let's just log the access token just to confirm it actually works. And we do get a valid access token here. I think this access token is good enough for the backend, and the backend can just verify your identity using it. I could be wrong. One dev on the front end, one index.ts on the back end. Ooh. Forgot app.listen 3000. And then now, let's try it. Let's go to the front end. All right, freeze frame. I don't know. Let me tell you something about browsers, guys. Can you see over here? There is one old front end tab that is open. This thing right here. And can you see over here? There is the new front end tab that I'm opening. Both of them started to conflict with each other when it came to the token that was stored in the local storage. So this guy started overpowering this guy. And what was happening was a very weird jar that I was seeing for a really long time. In the process of trying to fix it, I've done a bunch of things. Eventually everything works now. Nothing has changed much since I stopped recording. But this is like 30 minutes of me just figuring out something is wrong, or I'm just going crazy, or I'm just too sleepy. But the answer just was I had another tab open which was just conflicting with the local storage in this new tab and just causing everything to break. Now code wise haven't changed much. I was seeing a bunch of Supabase warnings, and hence what I did was here, in the top level app component, I initialized a single Supabase client, and then I just passed it to an app wrapper component, which is doing all the re-rendering, everything after that. The reason was there was a warning that I was seeing in the console, which was saying this client is being reinitialized again and again. I thought the warning is what is causing the bad issue. Again, it was just the other browser tab that was open. And hence, that's the only thing that has changed. I've gotten rid of the Supabase, the use Supabase, or the use, whatever that hook was. I think the use Supabase hook. In the middleware, it ended up working. So the user object that I get that we were logging before, somewhere in that user object, a very complex object, the user's address is hidden. And hence I just, picked the address, stored it over here in the address field. If everything is good, just, forward the request to the next handler in the middle, in the request chain. If not, let the user know things are incorrect. So now if the backend is running, which indeed it is, and I am logged in over here, if I click here to buy, and look at the network tab, you will see the request goes out, and I do indeed get back a message hi from the backend, which means an authenticated user that is sending a token as a header is able to hit the backend. But if I log out over here and try to hit the endpoint again, I see an error because, well, I can't just fetch the access token from the backend. But either way, even if I send a wrong access token, if I take this request and send it with a faulty JWT, my request will be blocked, which means we've been able to figure out auth on the front end. We let the user sign in with Solflare, they approve, and then we let them hit a bunch of endpoints. Our backend authenticates them using their Superbase token, and then lets them do the respective functionality. Which brings us to the next thing we have to do, which is implementing the respective functionality. This one does nothing right now, neither do the other endpoints. Authentication is figured out. Hence, the next step is probably writing the database schema. Let's do that next, and then we'll move on to implementing the backend and finally the front end. Let's implement the database schema next. Alrighty, folks, let's initialize a fresh package which will store all of our database schema, ORM, things like these. So let me go to packages, do a mkdir db, and then do a bun init inside. Here I'm going to use Prisma as my ORM, but feel free to use whatever. I think Drizzle is a cool one. Syntax wise is not too far off from Prisma, and Prisma is sort of losing its touch a bit. But I'm going to stick with Prisma for this one. Add the right dependencies, do a bunx Prisma init, I think. Go to schema.prisma and start to write your code. So in our case, we're going to have this will be a little tricky actually. I remember writing it, but now my machine ran out of space, so my Excel drawer is empty now. Let's quickly write what all we'll have. We'll probably have a users table, even though we probably don't need it because all of our user information is separately stored in Superbase. Other than that, we'll have a markets table. So this will contain things like for a specific ID and a title of a market, a description of a market. That should be it mostly. We'll have a order books table. We should probably have this as well. Users will probably have an ID, wallet ID, or wallet address, or let's just call it address, and then maybe just maybe their USD balance, which is how much fiat they have in this account. So if you go to my Polymarket, I had like $800 in there, if you saw in the beginning of the video. This will be a market ID and the complete order book, maybe like a sell order book and a buy order book, or let's call it yes order book and then a no order book, even though I think one is derivable from the other. I think so, but okay, let's just stick to yes and no order books for now. And maybe a total quantity available. So for every market, there's like X number of stocks, yes and no stocks currently available in the market. So let's just maintain that quantity as well. We have users, we have markets, we have order books, and we have positions. That's how much position of a yes or a no a user holds. So it will be something like this user ID for this market ID has these many yes quantity and these many no quantity. I think that should be fine. Or we can have separate entries as well. So something like this type, which could either be yes or no. Is that it? I think that should probably suffice. I'll call this positions. I don't think we need anything else. If we do, we'll come back to this, but I think this is probably all we need, at least for now. I'm sure I'm missing something, and if that's the case, we'll come back to it. ID, which is a string, which is a primary key, and it defaults to UUID. User will have a wallet address, or let's call it address, which will be a string, and then lastly USD balance, which should be sheesh. This is where things get tricky. You can make it an integer. Ideally, it should be an integer, and we should assume the final value stored here. If a user has $100, the value stored here would be 10000. If a user has $100.11, the final value stored here would be 10011. So we'll assume a decimal of 2 for fiat balances, and hence an integer here is fine. Model market. Every market will have an ID, a title, and a description. Ideally, markets should also have resolution. Basically some text that tells how exactly it's decided if a market is resolved to a yes or no. So there's there needs to be some clarity around what leads to a yes, what leads to a no, and if there is some ambiguous case that leads to a 50-50, what is that? You should mention that very well. Ideally you should be listening to some sort of an oracle for the final decision, but let's not go there. Order books. So every market ID will have an order book. So this is like a 1-to-1 relationship, so might as well merge them. Yeah, I don't mind. Yes, order book. Although I don't know about this. The thing is, let's not do that. We could do it. We could merge them because it's a 1-to-1 relationship. The problem is, we'll be locking these order book rows from time to time whenever an order is placed, and if this row is locked, other people can read it when the row is locked. So I guess it's fine. 2 people can't write, but other people can read, so that should be fine. Yes, order book, which will either I technically be like a JSON, and then no order book, same thing. And then total quantity of stocks available in the market, which would be an integer. Great, that's market. And then so we've just merged both the tables. No need for 2 separate tables. It was a 1-to-1 relationship anyways, and hence I can just get rid of this and this. And lastly, every market can have multiple positions for multiple users. So a position will have an ID. It will also have a user ID, which is the user that started this position. It will also have a market ID, which market is this position for. Then it will have a type, which will be a position type. Enum position type, which would be either a yes or a no. And that should do it, I think. A user can have multiple positions. So let's just define that through relationships as well. A user can have multiple positions, position array. A market can have multiple positions, so position array. And then every position can have or will have a user associated with it, which is a relationship between the user ID field here and the ID field in the users table. And similarly, every position will have a market, which is a relation between the market ID field here and the ID field over here. I think that's good enough. That's all we need to describe the schema of our application. We might be missing a few things, but we'll get there. If you're missing something, I think we're fine for now though. Does this cover everything? Should I think maybe something? Actually, we need a history of orders. Yeah, so model history, or order history. Every user will place a bunch of orders, right? They would buy a position and then they would close a position. So I'm thinking there are like a few ways to do it. A position can actually be a little more complicated. It can have a status. Is this currently an open position? But you can just partially close positions as well. This will get tricky. Position represents how much of stock I currently hold, of a yes or a no I currently hold. I would probably create another table called closed positions, or probably just orders, order history, which contains all of my buys and sells, or splits and merges. Yeah, I think that's good. Yeah, then let's do that. Let's have another table that has a history of all of the orders that I have initiated. That could be a buy, that could be a sell. So, or a split or a merge. So, order type would be an enum order type. Buy, sell, split, merge. And it would have things like quantity. So how much did I buy, how much did I sell, how much did I split, and how much did I merge. And price, which is irrelevant for splits and merges, but sort of relevant for buys and sells. Prices can also be integers, so it'll basically be anything between 0.01 to 0.99, but we're going to store it as integers, so that will be anything from 1 to 100, but we need to pad it down or divide it by 100 when we eventually show it on the front end. Great. We can actually do a bunch of things here. Here comes an interesting idea that'll make our lives a little easier. No mind. You know what? It won't. What I was thinking was, let's break down the order book. So, the yes order book and no order book into like 100 buckets. So, yes order book 1, price bucket, yes order book 2 price bucket, and then, 100 such buckets for yes and no. The goal was to make sure there's less contention, less locking, because we just break down rows into multiple smaller sub rows, so we can just lock a bunch of rows. We don't have to lock the full order book, although that's not the best thing in the world for multiple reasons. It won't really solve the problem, and it'll just make the logic more complicated. We might have to lock everything because whenever an order comes, you don't know how much of the order book you're going to eat. So long story short, there is probably a way to a path to optimizing this to lead to less contention and less locking, but we'll leave it at that for now. Cool. Order history, yeah, I think that's good enough. Oh, user ID, of course. An order is associated to a user and also to a market, so that will also be a string, and pretty similar things here. Every order will have a user and a market. Every user will have multiple orders, which will be an order array. Every user will have every market will have multiple orders, which will also be an order array, or let's call it an order history array. Beautiful. That should cover it. So if you look at Polymarket, it lets you see a page where you can track your portfolio. People can track their portfolio as well. It'll just be their USD balance plus all of their open positions ka PNL, which is like something you can calculate on the front end. People see their existing orders, their closed positions, which is the order history over here. People like to see their open orders, which is what positions they're currently holding, and whenever a market closes, we can just move them from here to here, or force close their positions. We can probably add another status field here. Never mind. Basically, we can add another field here that states, was this closed by the user by pressing a button, or was this just closed when the market closed? Either way, I think that's fine. We don't really need it. Market should also have a resolution, which will be an optional field, which basically will tell did the yes side win or did the no type win. So I'll just leave it at position type. I'll also make it optional. It is. How did am I tripping? Was I smart enough to write resolution before? Oh, this is something else. This resolution was resolution description. What tells this is just text that tells how do you resolve if this market is good or not, or if this market lands at a yes or a no. For example, you clearly need to write if Rajasthan Royals wins is when the yes stocks are going to give yes. If Rajasthan Royals loses is when the other side gets a 1, and if there is a draw, then both of them resolve to 50 cents, something like that. Cool. Slightly more complicated architecture. Let's visualize it. Let's go to a Prisma visualizer. Which one was it? There are a few here. I just made this so hard. Studio. 1x Prisma Studio. One add .env and then 1x Prisma Studio. I have to go to package, .env in my DB, and replace this with a local Postgres database. Postgres at localhost 5432, and let me also quickly start Postgres locally. Let me start Docker, inside which let me quickly start Postgres. There we go. And let me start it with the password of Postgres as well. So now I've started a new Docker container that is running Postgres on 5432 on my machine. I can simply connect to it. Password and username are both Postgres, and the DB name can be anything. In my case, let's just make it prediction market, something like that. Now if I try to do a 𝗟𝗟 Studio, let's see what happens. Okay, something opens up, but I haven't yet migrated the database, so it's broken. Let me migrate the database. 𝗟𝗟 migrate dev. Now it has migrated. There we go. And now 𝗟𝗟 generate to generate the client. And now 𝗟𝗟 Studio to visualize it. Let's see. There we go. That looks good to me. There is a lot of relationships over here. Remove that. All right. We have a users table. Every user has many order histories. Every user has many positions. We have markets. Every market has a bunch of positions. The market has a bunch of order histories. Actually, this isn't very complicated if you look at it. Cool. Now that is done, let's get into what? I think it's time we get into exporting a few things from this DB package. So let me quickly go to index.ts here, and there's some boilerplate that you can copy from this 𝗟𝗟 plus 𝗟𝗏 docs, or you can write it yourself if you want. This thing right here, which basically exports a 𝗟𝗟 object that I can export from this DB package here in package.json. Where is it? There it is. Export or exports. I think it's export. Dot slash index.ts. Now the DB package exports the 𝗟𝗟 client. The backend package can import the 𝗟𝗟 client by going to package.json here and adding DB as a dependency. Let's do a global bun install, and that should add DB as a dependency to the package. So now if I go to backend/index.ts, hopefully I can do a import 𝗟𝗟 from DB. I don't see any type errors, which is beautiful. Can I do a 𝗟𝗟 dot market dot find one? There we go. Seems like we've been able to write all of our DB logic here inside, the DB package, which we can reuse in multiple apps. Right now we have a single app, which is the backend app, where I am importing the DB package, the 𝗟𝗟 object over here, which is dependent on the generated client over here, which has, everything auto-generated from my schema.𝗟𝗟, which I wrote over here. This schema.𝗟𝗟 is my single source of truth, exports the client, which I have imported over here, and now things become much simpler. What's left is implementing the real backend logic. Beautiful. The most interesting part. Specifically, the interesting part here is the magic engine, which we'll be building, over here and over here. Splits and merges should be very simple DB calls, and then get balance, get positions, get order history should also be fairly simple. Yeah, let's get into it. Let's get into the difficult bits. Let's start by implementing the /by and the /cell endpoints, and then we'll make our way down. Let's get into that next. Alright guys, before we proceed, let me share a bit around locking rows in Postgres databases. I hope by now it's obvious why certain rows need to be logged whenever an order is placed. So if someone places an order, which means they're trying to change the order book, it should never happen that two people parallelly change the order book, or two people write to this order book, be it the yes order book or the no order book, at the same time. Hence, whenever someone places an order, you first need to lock a specific row. For example, if someone wants to buy certain yes stocks of the IPL token, or IPL whatever, this specific market, we first need to lock this row before another order touches the order book. First, this row needs to be logged. The data needs to be fetched. The data needs to be updated. Matching needs to happen. And then this data needs to be updated back in the database. Then we need to unlock this row so that the next order can take this specific row, so on and so forth. This will ensure whenever there are writes to the yes order book or the no order book, they happen serially and not parallelly. How do you ensure that in Postgres is, I've written some examples over here that will probably, help you understand that better. If you look at what's happening over here, which I don't think we need that, I've mildly implemented certain like two endpoints over here, which are sort of wrong. We'll not implement them like this eventually, but for now, when the user sends a buy order, which means they're trying to buy a specific stock of a specific market, we get the market ID from the request body, and then we do a prisma.transaction. This is, if you know what prisma.transaction does under the hood, it just sends a begin SQL request to the database, and what that will do is everything that happens from here to here will either happen together or none of it will happen. Specifically, if the query that you're sending in a transaction looks like this, select star from market where ID equal to this market ID for update. Specifically, this is the syntax that you send. What happens is that row gets logged until this transaction is either reverted or committed. Hence, this one line of code will ensure that that specific market row is logged, and then you do your thing over here. I've simulated a empty promise here for now, but whatever you do over here, there can be other people reading this specific row, but no one else can write to it. And hence, if you try to update this specific market, and eventually when the transaction ends, so you commit the transaction, is when this row gets unlocked, and then the next transaction can sort of pick it up. To show that in action, I've implemented this endpoint that simply gets that row, waits for 3 seconds, and then updates. And then I've written another endpoint, which again gets a market ID and tries to do an update. In the end, @get slash market is not going to do any updates, but just to show that locking works as expected, if there are two endpoints, both trying to update the database, and one specific endpoint locks a row, the other endpoint can't update the same row. So if for the same market ID, I send a request here and here, you'll see, the second one remains blocked until the first one sort of finishes, and the first one will finish after 3 seconds. So we'll see sort of, that sort of a delay over here. Let's open Postman on the right. Let's open Google Chrome on the left. And let me start the backend server. It already is started. Let me send a request to localhost :3000 / market market ID equal to 1. So when I send this request, it does an update. It also returns you the market. Right now, look at it, it's able to update it perfectly. But now, if I copy this and keep it handy over here, don't press enter just yet. If I send this buy request, while it is stuck for 3 seconds, notice this is also stuck because this is also trying to write, but it is waiting for the lock to open up. If it is not logged, you can update this row as long as you want. But if this is logged, the other guy also remains stuck until this gets unlocked, and the other guy gets the opportunity to update that row. So that's how you implement locks in Postgres. In our case, we need something like that. We need basically a lot of in-memory operations to happen over here, the actual matching to happen. And while that is happening, if there is a second request that comes over here, it shouldn't be allowed to update. This will be ensured through this lock, and hence, given we understand this syntax, we can now get into the meat of the business logic, and actually implement all the endpoints that are left. So that's now get into implementing the endpoints, assuming we understand how to lock and unlock rows. Alrighty, time to start with the most complicated endpoint over here, which is going to be the /by endpoint. The user is going to send us a market ID. The side, let me just create like a Zord schema for this. Bun add Zord, and then let me create a types.ts. Types.ts, import z from Zord, and then export const create order schema equal to z.object. It will have a market ID, which is a string, and a side, which is going to be an enum, which should either be they're trying to buy, a yes or a no, and then type, which is going to be, are they trying to buy or are they trying to sell? And and then the price at which they're trying to buy, which we're going to stick with integers over here. Is there an integer here? Seems like it. And a quantity, which again we'd probably stick with integers. So if the user sends us 100, that means at or let's say 10, that means for $0.10 price bucket, and if they send us a quantity of, let's say 1, they want to buy 1 quantity. If they send us a quantity of 10, they want to buy 10 quantities. So no decimals over here, but there are decimals over here. The user is sending us an integer. We need to divide it by 10. That's the actual number of stocks that they're buying. Or that's the amount of US dollar we need to reduce from their account. Cool. Backend. Now I'll import this const success comma data equal to create order schema dot save parse rec dot body, and then if not success, that means user sent us something wrong. Then simply do a rest.status 411.json. You've sent us something wrong, or message incorrect inputs. And then if everything is right, is when we're going to basically do this. We're going to hit the database, get that specific market from the database, and try to match the user's order. So rather than having a 3-second thingy over here, what we're going to do is const order book const response equal to this thing. And how do you give it a type here? I think like this. Schema.prisma. We have a yes order book and a no order book. Both of these are JSONs, so probably strings. I'll have to check this actually. Might have to parse those strings. Let me just log this response. Honestly, I'm not sure if this is exactly what we get or not. And then we'll continue with the matching logic. We will eventually have to update, but we'll come to this when we come to it. The update is just going to update the order book based on whatever matches have happened. But before we get there, let me quickly I've already created a market ID, market with ID 1 in the database. Let me send this by request for market ID 1, and it says incorrect inputs, which is great. So let me quickly add side, which is going to be a yes, and then type, which is going to be a buy, and then price, which is going to be, let's say 10, quantity, which will also be 10. Now let me send this, and this time it says market ID is not defined, which seems like a decentish error. This is going to be data.market ID. Let's try that one more time. This time, okay, this is what we get. We get an array of this, which is fine by me. An array of this. We'll have a bunch of other things. So ID, that will be a string, and then do we need the rest of the things? Probably not. But let me just keep them for now. Cool, I think that much is good enough. So can I do a response of 0 dot, there we go, const market equal to response of 0, and then if not market, then return, which basically means we can move on. But if there is a market, then const odd, yes order book equal to json dot parse market.yes order book, and then no order book will be the same thing. And given these two is when we need to start matching. So if this is where things get very long, complicated, and arduous, writing the matching logic. If the user wants to buy a yes stock, so if data dot side equal to yes, if they want to on the yes stock buy, then we need to basically, oh boy, there are a bunch of other rows we need to update, don't we? Or lock. If you remember, originally we discussed this, that this is not the only row that needs to be logged. It is this row and the user's balance and the user's one more thing which I'm forgetting, the user's positions. All three need to be logged. So this is going to be a select star from user where user id equal to 1, yeah, where id equal to basically rec.user id, which comes from the middleware. So let me quickly apply the middleware here. Const user id equal to rec.user id, which, oh boy, wallet. From the middleware we only get the wallet, unfortunately. I would actually update the middleware a bit. Yeah, unfortunately, since what the front end returns us is just the address, and this may or may not exist in our database already, because when we sign in we directly talk to Superbase, never talk to our own database. In the middleware we should ideally do something like this: await prisma dot user dot upsert, which means either update or insert. Select address is this specific address, and then update with address, and that's it, right? Balance, which is just be 0. Cool. Oh, actually we don't have to do that. Update just the address and create the address and USD balance as 0. That should do it. The thing is, it doesn't work because it thinks address is any, but address is actually a string. Huh. Oh no, select nahi hoga na. Where address. Okay, upsert syntax prisma. Where update create. That's what I wrote. Where I think needs to be it needs to have a, what do you call it, an index on it. Index on address. I think this is necessary for you to be able to basically upsert. I could be wrong. Let's go back to the DB. Let's do a migrate again. Added index. Let's do a generate again. And now let's go back to the backend and see. This got fixed. It did not. What if I do where ID equal to something? Then it works. But if I do where address equal to something, it fails. Is that a problem? Everything is optional here. At least ID is needed. Why? Why does upsert require at least ID? Upsert require at least ID in Prisma. I'm sure there's a way around this. Yeah, there we go. That's what we need. And the answer is, wait for it. So it's a combination of, oh, it needs to be unique, I think. Not indexed, but unique. That's my bad. Let's add, which, will be true for us. Let's add at unique here, and then migrate. Sure. Add unique. And now generate, and now there we go. This works beautiful. We upsert, which means create or insert const user equal to this thing, and now user db. You can actually do this, user db.id. Perfect. Now the user ID you get here is actually a string, which you can do a lot with. The thing that we want to do is where ID equal user ID. So this row also remains logged. And the third thing we need to log is this user's. Do we need to log this user's positions? Probably not, right? I think we're fine. I don't think we need to lock the user's positions just yet. We might have to, I don't know. But I think we're fine. All right. Yes, order book we have, no order book we have. Once the user says yes, what do we need to do? Number one, we need to check, do they have enough balance in the database? So basically, const response equal to this thing with an array of ID string, address string, and then USD balance, I think number. Correct. And I'm going to call this user response. We need to check if if the user wants to buy yes, then const USD that they need to spend is going to be the amount that they want to buy. So that's going to be data.quantity into the price at which they want to buy. So that's going to be data.price. Yeah, I think this is perfect. This is the US dollar that they need, and the price is also bumped up by 2 decimal places, and so is the US dollar balance. So this is fine. If user.usd balance response dot actually let me do this also. Const user equal to user response of 0. If not user, return. And then if user dot USD balance is less than USD, then we can simply say rest.status. We can simply return early from here. And we should also do a rest.status 403.json message. Sorry, you don't have enough dollar in your account, something like that. That's fine. But if they do have enough dollar in their account, what do we need to do? We need to start matching them, which is always the tricky part. What we need to do is iterate over the yes order book, which we should define the schema for at this point. So if I go back to types.ts, let me quickly write type order book. I'm going to keep things this simple. Every order book is going to be a map from a string, or actually it's just going to be an object. So let's just stick to that. From a string to that's the price bins, right? To something like this. Available amount at this price, available quantity at this specific price bucket. So that's going to be a number. And then individual orders that are available to be matched, which is going to be an array of user ID, which is a string. This user is sitting on the order book at this specific price with this much quantity, and this much of their quantity is already filled, and this is the original order ID for this user, which is basically the ID in the orders table whenever they created this specific order, or the order history table basically. Anything else? No, I think that's good enough. Yeah, that's fine. Array of this, and now we'll go back here and say, okay, this is going to be an order book. Did I not export it? I did not. It's going to be of type order book. We should ideally define that as a, what do you call it, a XOR type. So and just save parts from the DB, and if things are bad, just let the user know. But let's say we don't do that for now. If side is yes, and if US dollar balance is less than USD, then nothing happens. If it isn't, though, we try to match the user. So we say let filled quantity for this user is 0, and we iterate over the full order book in a sorted fashion. So we're going to do a object.keys of so if the user wants to buy yes, we need to look at the yes order book, dot sort a comma b, a minus b, where a is number and b is number. I'm unsure if a minus b is correct. We'll see if the other one is correct. But what we want is, if the user wants to buy yes, we need to show them the lowest price at which it is available. And what's the problem here? Oh, why is it strings? Yeah, number of this thing minus number of this thing. It is strings because that's what we mentioned over here, even though key should actually be a number. In that case, you don't have to do that. There we go. Cool. Keys will always be a string no matter what. I say sorry, my bad. This was correct. Yeah, no matter what you do, this will still get converted to a string. Cool. Const prices on the current order book looks something like this, and then prices dot for dot map or for each either is fine. Price const order at this specific, or const bucket I would call it, or const available quantity comma orders, ये ना दो चीज़ें equal to of price. Yes, order book of price, and I don't know why. Oh, quantity and orders, that's fine. If price is greater than the price that the user wanted, so data.price, then we can simply return. It just means we weren't able to match this user at this price, and probably are not going to match any further as well. Price is from string and number. Yeah. But if that's not the case, then we try to match this user and try to get them matched with the specific person sitting on the other side. Will quantity comma orders is this thing. Quality, we have the orders. If available quantity is actually, we can just keep going over the orders, right? So orders dot for each, like man does this get recursive. Order, if order dot quantity, what's the problem here? Why doesn't orders have a type? It's undefined. Assume it exists. If order dot quantity is greater than or equal to the quantity of this specific, that the filled quantity, I would say left quantity, which is going to be data dot quantity, is greater than equal to left quantity, then you can simply say order dot quantity minus equal to left quantity, and you can say a match has happened, and it just ends over here. We can say left quantity equal to 0 in this case, and since a match has happened, we need to touch the database heavily here. We basically, there are a bunch of things that need to happen now. An order has happened, right? So from the database, again, there are like more optimal ways of doing this, which is something I probably want to do. What I can do is I can just let's just keep things simple for now. We can optimize this later. Await the other user's position change. I know. I feel you is like very complicated. Never easy to do this in the first go. What is going to happen is कि दो users का match हो गया है. So await db dot or prisma dot position dot update, sync await promise dot all these. And there are like better ways of doing this. This is a little unoptimal. Kill me now. Promise dot all of this thing. If you know async programming, you do. If not, I'm not going to explain. This is like, if you know async programming, this is like obvious what I've done here. If not, well, you have some reading to do, my friend. Update where user ID is the ID of, let's say, the second user. पहले second user का काम कर देते हैं. So the person whose order got matched, which is ordered user ID, and डेटा अपडेट कैसे होता है यार, फिर भूल जाता हूँ हर बार. वेर यूज़र आई डी इज़ दिस एंड प्रॉब्लम क्या भाई तुम्हें इसमें स्ट्रिंग सही तो है. डेटा their so they sold, so their USD is their oh, market and market ID is something, you know, data dot market ID. Their yes stock is going to go down, so you know, position should have a and type is yes. This thing should go down because someone else bought their yes, so their yes quantity goes down. Man, why did no one stop me when I created a position and forgot to put quantity here? Yeah, quantity is going to be an integer, and then migrate, added quantity, generate, that's done. Quantity needs to increment by, decrement by how much? Basically left quantity जितनी रह गई उस बंदे की. And what's the problem here now? ID is missing. You need the ID only. बिना ID नहीं होगा. I think we need a little bit of uniqueness constraint here. A user ID and a market ID will always have a single entry here, and a type. These three. A user can only have one entry in the positions table for a specific market and a specific type. Another migrate, added constraints, another generate, forgot to give the name, but it's fine. Going back to the back end, now, अबे चलना चाहिए. Generate, oh, db, generate again. User ID market type डाल तो दिया. User ID market type for position. This should work now. Let's see, it did not change. Sorry. Where this thing is, you know, this. There we go. I know Prisma can get very weird, especially when you're trying to update. But now it should basically lets you update on indexes. In this case, you know, the index is the user ID market ID type index. Now that is cool. एक बंदे की quantity कम हो गई. Of course, दूसरे बंदे की quantity बढ़ जाएगी. So that is going to be a, you know, update where this is going to be rec.user ID or, you know, user ID, and this guy's quantity is going to increment by the same thing. And now user dollar balances also need to change. So इस बंदे का user balance बढ़ जाएगा. Whoever's quantity has decreased, their user balance will increase. So prisma.user, and this is where we need to lock the other guy's balances. Do we? We're just increasing it. Yeah, we still need to do it. Actually, maybe not. We're just increasing it. That's fine. Prisma.user. It'll just work. Thankfully, it'll just work. Update where ID is the ID of the second user. So that's going to be order.user ID. And, you know, data is going to be their USD balance is going to go up by how much? USD balance is going to go up by the price level. So that's order.price. Yeah, that's order dot. Man, did I forget the price here? Position has a quantity. No. It'll be the price bin from here. So price into you know, whatever this quantity was. So left quantity in this case. And then convert that to a number. And then, you know, similar decrement for the other guy because, you know, user balance एक का कट रहा है, दूसरे का बढ़ेगा. This will be rec.user ID, and this guy's USD balance will go down because they're literally trying to buy a stock, right? Their things should go down. Their balance should go down. All right, a lot of things here. Only if, in this case also A condition is met. There needs to be an else here also. Actually, we can make this a little cleaner. Const matched quantity equal to, if this is the case, then left quantity, else it will be order dot quantity, and let's just do all the matching with just left quantity, sorry, the matched quantity, my bad. So copy matched quantity from here, and wherever I'm using left quantity, which is this guy and this guy and this guy and this guy, just use matched quantity, and then we can say order quantity minus equal to matched quantity, and left quantity की ज़रूरत है वैसे अपने को, और क्वांटिटी ज़रूरत है नहीं, ये तो हमने ऑलरेडी कर दिया. That happens in the database. Left quantity minus equal to matched quantity. Beautiful. That's the quantity left for this user. Man, that's already a lot of lines of code. For just matching the yes ka by, I would assume, if data.side is yes, and the user is trying to buy, and rec.user, so no, user is trying to buy, so that's going to be data.type equal to buy. If the user is trying to buy a yes, a lot of things happen inside this. Now we need to do if the user is trying to sell a yes, and data.type equal to sell. Then a whole different ball game. Actually, maybe pretty similar. This also might be wrong. How do I have everything here? I think I'm just iterating through this a little too much. And I would never decrease the available quantity in the yes order book. Oh, I never update the order book either, which is something I should do. There's a bunch of things I should do and I haven't done. Number one, I should update this yes order book as well in memory for now, and then eventually, shove the updates in the database. So yeah, what we're going to do is, a bunch of things have changed. Yes order book of price dot orders, or dot orders. Don't need to iterate again. Probably we can simply say order dot filled quantity plus equal to matched quantity. Order dot and yeah, we can actually remove this also, but that's fine. Orders, or yes order book of this price level dot available quantity minus equal to the matched quantity. I think that should do it. Increase the filled quantity, do this thing, and if order dot filled quantity equal to order dot quantity, then also remove this order. Probably don't do it here, though, do it later. It'll just, while iterating through an array, probably not the best idea to delete elements from that array. So I'm just going to stick to this for now, and then eventually we can just clean the whole thing up. Cool. That now updates the yes order book as well, which eventually we will shove into the database. Let me just, update that. Dot update where ID equal to rec dot, data dot market ID. And let's update the yes order book and the no order book to again, JSON not stringify yes order book, JSON not stringify no order book. Beautiful. I think that's great. A lot of database calls here, which is not great because there's just too much back and forth between the database and the backend, which there are ways to optimize, and we should talk about it. We should basically club a lot of database updates together. As you can see here, I'm doing 4 database updates for every match that happens. That is not great. We should only do one bulk update when the time comes, but let's just, write the logic once and then we can optimize it further. I think now the yes side and buy is done. Let's do the yes and sell. For yes and sell, the user wants to sell some quantity. So, oh, there's also more things here. This is like this might be a partially filled order. Like it might happen the user's full, left quantity is still, there's still some left quantity here. If that happens, we should try to put it on the order book. Nahi to, we're basically saying people can never put orders on the order book. So we'll always have an empty order book, which is something we don't want. So if there's a left quantity, what we need to do is order book, order book of जो भी price level user का था, user's price level. So that's going to be, data.price equal to check that. If not this thing, if it doesn't already exist, then, initialize it with fill, what was it again? Available quantity and orders. So with something like this, available quantity 0, orders empty array. And now once that is oopsie daisy done, is when we're going to do what? We're going to say yes, order book of data.price does exist, dot available quantity plus equal to left quantity, the quantity that is left for this user, and also dot orders dot push quantity is this left quantity, user ID is, rec.user ID or whatever is up there already, filled quantity is 0, and then original order ID is something we can add. We can probably create a UUID somewhere here and just, shove that in here. Do we really need the original order ID? Probably do. Yeah, we do. So let me just, create one over here. Const original order ID, can be a random UUID. Let's just do that. So one add UUID, and then I can simply say UUID import v4 from UUID at types slash UUID. अबे UUID v4 होता है क्या? Yeah, that's the one. v4 from UUID v4. Cannot find you. Where am I doing all of this? In the wrong place for sure. One add UUID v4. Now import v4 from this, and then hopefully, we can call v4 here, which returns क्या है UUID v4. Okay. अभी तो दिखा रहा था as UUID. Okay, never mind. There we go. Is that a string? It does return a string. Great. So we have the original order ID. Let's put that over here. Beautiful. Great. That covers buy and yes now. Hopefully it does cover it now. It's like 40 to 120. That's like 100 lines of code they have to write just to do one thing. To do the second thing now, if you want to, sell a yes, you basically again have to iterate through the yes order book. Or do you? The yes order book. Things will get very tricky now. The thing is, the yes order book, what we're saying right now, or what I am stating right now, is only contains who is willing to sell a yes stock, and the no order book simply contains who is willing to sell a no stock. And if you come to the market to sell a yes stock, that means you have come to the market to buy a no stock. Does that sound like a relevant explanation? If I want to sell a yes stock, I already have one yes stock. If I want to sell it, it's equivalent to me buying a no stock, right? If as soon as I buy a no stock, they immediately get merged. A yes and a no merges to $1. Hence, it is actually equivalent to me buying a bunch of no stocks at the price at which I want to sell the yes stock. को वन में से निकाल दें. तो if I want to buy yes or if I want to sell yes at 70 cents, it's equivalent to me wanting to buy no at 30 cents. So what I to buy no at beautiful. That changes a lot of things. That makes the logic much easier because that also means कि if you are trying to or if you are simply trying to sell a no, that is equivalent to you trying to buy $30 of a yes. Just price change हो जाता है. So let's basically say const order price equal to thinking, guys. Selling a no, खरीदूंगा and खरीदते merge करूँगा तो वही है ना. I mean, probably still needs to be 4 different if else statements, even though there'll be like a lot of repeated code. Probably makes sense for there to be 4 separate ones. Let's start with a no and a sell maybe. No, actually let's do a yes and a sell. Yes sell is equivalent to me buying const by price is nothing but 1 or in this case 100 minus order dot or data dot price. Const by quantity is basically the order dot quantity still, or data dot quantity doesn't really change. And now the logic is pretty similar, close to this. I'm basically trying to buy a lot of no's, which basically means I will do I need to do this check if I'm trying to sell? Probably not. The check that needs to happen is, do I have enough positions? No. My bad. Man, is this confusing? If I'm trying to sell a yes, that means I either need to have as many yeses. Not either. I probably do need to have as many yeses, right? Yeah. Also, did I ever update the I did? I need to have at least that many yeses. And if I don't have as many yeses, I can still try to buy a no. Probably not. Let's just check that up front. Do I have enough yes stocks to sell or not? Let's check that. So that's going to be do I already have this user's position for this market? I don't. Do I? No. So const user position equal to await db or prisma dot position dot find first, where user id is this user id, and then the position is going to be market id is data dot market id, and side or type is yes. Do I have enough yes stocks to sell in the first place? If user position dot quantity is, if not user position, then simply return. But if that is the case, if the user has some quantity, I need to ensure user has enough quantity. So quantity is greater than equal to what they're trying to sell. So data dot quantity, then it's fine. But if this is the case, data quantity is more, then we can simply return as well. Probably log some things here. If everything is good though, now the user, we can basically start with the same thing, right? Left quantity. equal to all of it. User wants to sell, data dot quantity, and that's left to be sold right now. And then I start again. This time though, I start to read from the other order. Yeah, I start to. I want to sell, right? Buy a yes. And I want to sell a yes. So yeah, I will sit on the yes order book. Where was I sitting over here with the left quantity at the end? I was sitting on the yes order book. Do I though? The yes order book simply represents people trying to sell yeses, and not. Yeah, the yes order book only represents people trying to sell yeses. The no order book simply represents people trying to sell nos. So if I want to buy a yes, that is equivalent to me. And वो नहीं मिल रहा है मुझे. That's equivalent to me trying to sell a no. Because if I sell a no at a specific price, then it is equivalent to me having bought yes at 1 minus x. I will always merge, right? Yeah. So, I need to buy yes, I need to buy no. Oh boy, beautiful. Whenever you are willing to buy, this will be a node order book. Long story short, I will not sit on the yes order book here. I will sit on the no order book. Believe it or not, you don't believe it. And this will not be data dot price. This will be const opposite price is 100 minus data dot price, and this will be opposite price. Basically, I was trying to buy yes. I couldn't find it. No one is selling yes at that price. So I'm now just willing to sell no that I don't already own though, which is weird. I don't own a no. How will I sell a no? Well, now I need to change the order books. Should the order books represent? Okay, here is a Polymarket Proton VPN. I think we didn't really describe the data structure very well. If you look at Polymarket, if I open the random, doesn't even have to be a binary market, this one right here. Notice, when I open the yes order book, it has something at 2.3 and something at 2. If I open the no order book, 98, 97.7. Do you see some resemblance? 100 में से निकालो कितना होता है 97.7. 100 में से निकालो कितना होता है 98. तो are these opposites? Yes, Harkirat. So effectively, are there two order books? No, Harkirat. There is actually a single order book. There is a single order book which has 2, 1.9, 1.8, 1.7 here. And if I just click on no, it just has 100 minus 2, 100 minus 1.9, 100 minus 1.8, 100 minus 1.7 here. And the same is true in the other direction. It has 2.3, 2.4, 2.5, 2.6 here. It has 100 minus 2.3, 100 minus 2.4, 100 minus 2.5, 100 minus 2.6 here. The quantities are also the same. 6.25, 200, 100, 200, 6. कहाँ गई 100 अब चेंज हो गई 100 200 822 200 100 200 822 200. You get the idea. The thing is, this is effectively like a single order book. It seems like there are two, but one is just the opposite of the other, and we need to clearly define what yes order book means and what no order book means. Right now, what the logic that we've written, yes order book simply represents the yes orders that are available to be sold. And no order book simply represents the no orders that are available to be sold. Yeah. On the front end though, we can show the opposite things as well, but that's like front end magic. That has nothing to do with that is not, people aren't actually sitting over here. Okay, cool. I think I have some idea now. All right. Assuming yes order book is people trying to sell, this logic is perfect, and the other logic is also fine, although I should probably store which kind of order this is in the order book. So the order book type will change a bit, and we'll add something like reverse order, which is a boolean here. Basically represents if the order book says someone is willing to buy no, were they actually willing to sell no? Were they actually trying to sell no? Or were they just trying to buy yes, and since they weren't able to find any yeses, are they now trying to sell a no? That is what this reverse order, thing over here means. And if I go back to index.ts now, the order that we're placing over here is going to have a reverse order of true. It's just representing the user's intent. Are they trying to sell a no stock? In this case, they're not. They're actually just trying to buy a yes stock. They're not able to find it. And hence they're like, chalo, I'll sell a no stock. But whenever it sells, the user will not have that much no stock in their balance. The user is just, the user is just going to do a split and a sell. Does that make sense? When the order comes, the user is going to split a bunch of dollars into a bunch of yes and no's, and then sell a lot of no's to eventually be left with yeses, which basically changes this logic a bit. Does it though? If the user says, I want to sell yes stocks, if from the front end they're saying I want to sell yes stocks, in that case I think it's fine. But a few checks change over here. A few checks change over here. Matched quantity is this, which is fine. Const reverse order is order dot reverse order. Now, if someone sold a yes, it's not necessary that we need to decrease their yes stock. They might not even have yes stocks. If it is not a reverse order, then this is fine. But if it is a reverse order, then we're not going to decrease their yes stocks. A lot of things will change, but let's just start here. If it is not a reverse order, this logic is fine. Is user के लिए तो यही होगा. The second user was trying to buy yes, and this is what will happen for them. This guy, if it is a reverse order, we will not increase their yeses. They were actually trying to buy a no stock, so we'll actually increase their no's, believe it or not. We're not decreasing their yeses, we're actually increasing their no's. Like here, that's very confusing. Well, I am with you, it is confusing. We're going to increase their no, and we're going to decrease their balance. Actually, there should be like balance locking, which we haven't covered, but let's assume people are not reckless like that. We shouldn't assume that though. There should be balance locking. We can add that later. We should decrease their balance by number of, I think this will be like 100 minus price into quantity. I could be wrong, but I think this might be right. Have you solved DSA before? This isn't DSA, but you get the idea. It's like very confusing. User wanted to sell a yes at this, that means are willing to buy a no at this, and hence, that's what ridiculous. Yeah, that's fine. It's basically a split followed by a sell, and it increases their no stock and not decreasing their yes stock. Harkirat, I think you have outdone yourself with this first if statement. I strongly feel this is like fine. We'll get like AI to review it or write some tests. But I think we got there. We were able to figure out what happens if the user tries to buy a yes. If a user tries to sell a yes, is the next question. Here, I think things are simpler. Selling a yes is either going to be buying. If I want to sell a yes, that means I might want to buy the no's from the book and then merge. That's probably what I want to do. So yeah, if you're trying to sell a yes, you're basically trying to buy no's at this price. So number one, we check, does the user have enough yeses in their account? If they do, we're basically going to make this user buy a bunch of no's which exist in the no order book, and hence I don't use this at all. We don't have to use it. Yeah, it's not needed. I should still check the sorting logic here. I'm unsure if this is right or not. Best price होना चाहिए ना, so either way I think it'll be this only. All right, copy pasta with a bunch of replacements. Man, this like really requires a lot of cognitive help. I think we don't need this. Let's just wait on that. All right, left quantity is this much, and then a lot of repeated logic on now the no order book. It'll still be sorted in a similar fashion, lowest price to highest price. We'll get all the orders over there, and we won't match them on order.price. What we'll, or honestly, if I want to keep the logic similar, I can simply change order data.price to basically this data.price equal to something like this. But that'll just confuse us a little bit more, so let's not do that. Data quantity is fine. By price. Wherever there is data.price, there will be by price. Which actually this might be the only place. Yeah, that's fine. Honestly, this might just do it. Let's see. Now, what will happen is the other user was trying to sell a no, right? You were trying to buy a no. So we will decrease their no quantity, or if it was a reverse order, we will increase their hold on, decrease their no quantity, increase their US order balance. This is fine, but in the else we will increase the yes quantity. I was trying to sell a yes, so they're the one who bought it, which is what they wanted, and I'm going to decrement again by, in this case I don't have to, do I have to? Probably don't. No, if it is a reverse order, then I do need to do it. So this will just be, will it be price though? It will still be price. Yeah, this is fine. Yeah, that's fine. Price into quantity, price into 100 minus price into quantity. Update the user's position. कि भाई आपने no, I was trying to sell yeses, right? So this time I'll decrease this. Yes, sir. And then I will I will. And I will increase my US dollar balance because I was trying to sell a yes and I was able to sell it. Beautiful. Left quantity, ordered filled quantity. Yes, order book will become no order book, and I think we're good to go. If by the end you're still left with some quantity though, so basically all of this is only needed if there is some left quantity. If not, then you're fine. Something like this. And then if left quantity, नीचे वाले case में, then we'll just put the user on the yes order book, right? He was trying to sell yeses and now he gets to sell yeses. So yes order book, and now not the opposite price, we'll give the original price. Beauty. Yeah, that's fine. That's fine. All right, guys. I think I've clearly, I don't know about you guys, but I feel like I've outdone myself in writing all of this logic. The matching engine is always the difficult part here, and we've implemented a yes buy and a yes sell. A no buy and a no sell is again a lot of repeated logic. This is like 300 lines of code in itself. If the yes and no are, the yes buy and yes sell is fine, then the no sell no buy is going to be just a bunch of variables interchanged. So I'm probably going to vibe code this one, the other two if statements, just that much. And also probably going to validate if everything is correct or not. I feel like I'm missing something. I don't know why at the back of my head I feel And also, I know, Devin is probably going to tell me this like the worst architecture, which it is, because there's a bunch of DB updates happening inside a transaction, which only lasts for like 5 seconds. But I'm still going to take a stab at this. Start Devin and ask it to finish the /by endpoint. And let's see what it does. Very curious to see what it does. Yeah, don't test the endpoint. I wouldn't test the endpoint there, one. Did it update anything? Let's see. So open index.ts again. Yes, by we did. Yes, cell we did. No, by it did. No, cell it did. I think. Oh, a bunch of catches. It added a try catch, which I don't care for. It's fine, I guess. But other than that, it didn't really complain about something missing over here, which I like. Even though I was using the fast model, so maybe didn't look at it. But I don't mind this at all. I have a yes by yes cell, no by no cell. I should heavily test this endpoint once. Write a bunch of tests that ensure it does work as expected. I'm going to just kick that down the curb for a bit. The market endpoint, once the difficult one is done, so let's just quickly finish the rest. Find first, and where ID is rec.query.market ID. Oh yeah. Where find first, where ID, there we go. String, something like this. Simply return it. That's fine. Oh, whenever new stocks are created, we should probably update the database. Something I've missed right now. There are a lot of to-dos. But anyways, we'll get there when we get there. App.post cell. Cell was a different endpoint. It's fine. Let's just change this to app.post/order because it just implemented both things, buying and selling. So we can actually get rid of this. A split and a merge. These easy. I think they're easy. Don't think they're too difficult. Basically, the user is going to give us something like, again, I should define a type for this in types.ts. Export type. Split schema equal to set.object, const, with again the market ID, which is z.string. This market k split, right? The amount, I guess, which is z.number, which again would probably be $1 gets merged to 100 stocks, right? So this is basically going to be if the user sends us 100, that means they're trying to split one stock. If the user sends us, they're trying to get one yes and one no. I think this will be this. Basically, the amount that we should decrease should be 0.01 ideally, but since we're storing the multiplied value, I think we're fine. Yeah, perfect. So basically, long story short, const data comma success equal to split schema dot save parse rec dot body, and then if not data dot success, then rest dot status 411.json message incorrect inputs. But if everything is correct, then what's going to happen now is the user is going to have a decreased US dollar balance by just the amount. So it's going to be a await db dot it actually needs to be a transaction again, but a different type of transaction this time. It can just be an array of transactions. So that will, or it's fine. Let's just do this. Await tx dot user balance. I first need to check the user's balance. And if you are updating the user's balance, you probably need to lock that row as well. Not probably, you do need to lock that row. And hence, we'll do something like this, followed by const user id string equal to rec.user id. This will be an async function. Get the user response once you have it. If user response dot balance, or USD balance, the 0th value, whatever, you get the idea. If user dot balance is less than data dot amount, that just means I should return here. That just means that the user shouldn't be allowed to do it. So rest dot status 403.json message, sorry, you are not allowed to do this, and return that transaction right then and there. But if everything is fine, the user has enough US dollars, then you decrease the US dollars. So that's going to be a await transaction dot user dot update, where ID is this user ID, and then data is going to be the USD balance is going to get decremented by this amount, which is data dot amount. That's one. And the second thing is 2 positions need to be created for the user. So that's going to be tx dot position dot create. Might be a create or increment. It has to be an upsert then. Upsert, where I get a bunch of things. Market ID, user ID, and then type by, yes. This is going to have a bunch of, this will be the complicated type that we created. There we go. Create would simply, create something with this market ID, user ID, type, and quantity of data dot quantity. Update would simply increase the quantity by data dot quantity, and now we're good to go. What's the problem here? Quantity आएगी भाई, डेटा में क्यों नहीं आएगी? Amount लिखा हुआ है, my bad. So you get the idea. This is going to be amount. This is going to be amount. And what's the problem here? Market ID doesn't exist, and that's because it is defined over here. Const this thing equal to data dot market ID. Beautiful. Crazy stuff here. Let's just define it slightly niche here. Beautiful. Update the user's balance and decrease the user's balance, add a yes position, add a no position as well. Again, like slightly unoptimal, like 3 database calls sequentially is not the best way to proceed. Even though they're a transaction, there are better ways of doing this, or faster ways of doing what we're doing. No will be exactly the same, right? There's equal amount of yeses and nos that the user gets in their portfolio. Yeah, that's fine. We should probably also always store, the price at which the user bought them, which can just be current price right now, because it's good to see your PNL. Even though it's like a delta neutral position, still good to see like a PNL. Split is cool. Can you guys figure out what merge would do? It'll again take like quantity as an input. and it would increase the user's balance, decrease the quantities, do a bunch of checks around. So can we ask Devin to do this one? It's basically the opposite of split. So I'm hoping, implementable. Can you finish the split endpoint? Let's see if it's able to do it. Sorry, the merge one. Sorry, not split but merge. Split I'm a little more confident in compared to the order endpoint right now, because I don't know, I'm just not super confident in the order endpoint at the moment. I feel like we're missing a few things. I also feel like there are too many database calls for it to be useful at all in production. Again, it added probably a bunch of try catches in a few places where it didn't need to. Split schema is again amount and price. That's beautiful. Oh, merge schema, sorry. Merge schema will basically be the same. So yeah, that's fine. Sounds good. Sounds good. There we go. Update. Increase the balance, decrease the amounts. Love it. Did it the first go. So we're done with the merge endpoint as well. We have an order endpoint that I think is complete, but kill me if it isn't. Get market should be fine. Split merge should be fine. Get balance should be, again, pretty simple. Hit the database, get the user's USD balance. Hit the database, get the user's open positions. Hit the database, get the user's open orders. I'm not sure if I've ever added an order. I should do that at the end or somewhere in the middle. After these 4 positions, probably add the specific order was placed by the user. Which basically is, the user was trying to buy yes, buy no, sell yes, sell no. Yeah, I should probably do that. Await. The intent of the user needs to be captured, which is, order dot create. What all does order history have? I don't even remember. Oh man, it has a lot of things. ID, though, we were going to force to, the original order ID, whatever we kept there. And then order type, was it a buy or a sell? This is rec dot data dot type. If that's equal to buy, then buy with the capital P, else sell. And then what else? User ID, price, quantity, user ID, order type, market ID. I think everything else is done. Market ID. What's the problem here? Data dot price, data dot quantity, data dot market ID. Beautiful. That's one. We should do it here. We should also do it in the splits and the merges. So whenever a user tries to split, one more database entry, please, which is going to be basically right after all of these things is fine. ID can simply, you don't have to pass one ID here. And here it's going to be a split. User ID is fine. There's no point of a price here. There is a point of a quantity here, which is the amount, and then the market ID. Beautiful. The same thing in a merge. So towards the end of the merge, we do this, and rather than being a split, it's a merge. I think we're getting close to completing the backend, guys. Split done, merge done, order done, which were the 3 difficult endpoints. Simpler ones were, I'm just going to wipe code them. It's like, get everything from the database for this user, get the user object, return the balance, get the position objects of the user, return the balance, get the history object, or the order history object, return the balance. It's like, let me implement one const user equal to user ID as string rec dot, or whatever, prisma dot user dot find first, where ID is this user ID. And given we have that, I'm going to basically say rest.json balance USD balance, something like this. That sounds good to me. And position history is going to be as simple as this. Dot positions dot find many hoga bas. and going to return the positions, and then lastly history, which is simply going to be the same thing. This will just be history, and this will just be dot order history. There you go, जी. Done hai. We have order history, positions. We did everything, man. I'm so proud of myself to pull off 800 lines of code. Oh god, kill me now. To finish the backend. I'm mildly underconfident about this backend, guys. I know I've done it, but I'm still. I wouldn't say I'm confused. I'm just, order books on prediction markets are a little weird. What makes them weird? And I suddenly remember this with a flashback of 2 years ago when we did Probo back in Super 31. What makes them weird is, in the end, there's like a single order book, even though it looks like, okay, there is one order book where you can sell for this, buy for this much here, and then one order book where you can sell and buy for this much. It's actually a single order book, which just looks the opposite as you go between both of them, which is what makes it interesting and tricky at the same time. That is why if you look at the logic, the order logic, there's a lot happening. If the user is trying to buy a yes, we try to go through the yes order book and see if we can match them. But if we can't match them, we make the user sit on the no order book. With reverse order set to true. Which is perfect. Actually, reverse order will always be true with what we've done. If you're trying to buy, that you sit on the other side willing to sell. But if you already have some and you want to sell, so this thing right here, either reverse order should be false. If I already have yes and I want to sell, in that case, if there is some quantity left towards the end, this should be false. Boy, I did not catch that. Guess who caught that? It was Harkirat. And then, true here is fine. And then if I'm trying to sell no, I really want to sell my real no's, and hence this should be false. There's a bunch of balance locking we haven't done, which we should do. I think I can just keep placing orders on the book, even though I don't have enough, US dollar balance. That's one. Everything else, I don't think from a call it security or functionality perspective I'm missing, but I am missing one thing, which is as you sit on the order book over here, your collateral should be logged, or your US dollar balance should be logged by a bit. And the reason for that is otherwise I just keep sitting on the order book with infinite orders. Cool, that's one thing to fix. Other than that, I think we're good to go. I've completed the backend, and the next step is writing the front end, which God thank me that I've been vibe coding front ends for a while now. So I'm going to just I'm probably going to add the balance logic and then vibe code the front end, because the balance locking is sort of important. We also need like an on-ramp endpoint, a deposit endpoint. If you remember the original architecture, I had like a deposit service and withdrawal service. We didn't get there, but we should add endpoints that let users on-ramp and off-ramp, and eventually those should be done by talking to the blockchain. Right now, I think this is as far as I'll go. So I'm going to add 2 dummy endpoints, on-ramp and off-ramp, vibe code the front end, add the locking logic to ensure if you're sitting on the book, your user balance is locked, and then vibe code the front end. We'll look at the finished product very soon, guys. I'll see you guys in the next section where we do all of this. Alrighty, vibe coding did its thing. This is what the website looks like right now. You can come to the website, sign in using your wallet. You can see the open markets. I've seeded a bunch of markets right now. You can see your US dollar balance, and we don't support deposits and withdrawals yet. There is a simple endpoint that you can call to increase your balance if need be. Positions shows all of your open positions right now. What yes stocks do you hold, what no stocks do you hold, and history shows a history of all the things that you've done. For example, I've split, I've bought a bunch of more times, so on and so forth. Let's look at one of the markets. These two markets have some shares in it. Will Bitcoin reach $100,000 by end of 2025? As you can see right now, the best yes stock is available for 62. The best no stock is available for 42. They sum up to 1.04. So as expected, the sum is greater than 1. These are opposite orders. There is a bid. That means someone is willing to buy a yes for 58 cents, specifically 140 quantity, and the equivalent on the other side, 42 cents में same quantity is available to be bought for the no stock. Someone is willing to buy this, or someone is willing to sell no. Same prices, by which I mean, they add up to 1 and the quantity is exactly the same, so on and so forth. A bunch of opposite orders here, a bunch of opposite orders here, same as Polymarket. If I open Polymarket, if you remember, there were opposite orders on the yes and the no order books. If there is a 98.2 and 2538 here, then there'll be a 1.8 and 2528 over here. Let's discuss a few edge cases or things. Let's say I want to buy yes stock at 62. Will I be able to buy? Yes, I'll just eat from here. So if I buy yes, this became 130. If I buy it again, this became 120, so on and so forth. If I try to buy at 61 cents, what do you think should happen? Is anything available at 61 cents? No. I am willing to buy a yes at 61 cents is equivalent to me willing to sell a no at 39 cents. So what will end up happening if I select yes here? I'll start to sit over here with this 10 quantity. And of course, over here, I'm willing to buy it at this or willing to sell no at 39 cents. What gets stored in the database is just this, and these are just front end, opposite manipulations to see what you see over here. This and this are what actually gets stored in the database. And that's it. That covers trading, balances, positions, history of everything that you've done. Splits and merges are two other things. Do I have any no stocks right now? Let me just buy a few no stocks. Did we add self-trade prevention? I don't think we did. I think I'll just end up buying no from me over here, which is not great. And we didn't clear the order book from time to time when we showed a bunch of, edge cases that are popping up now. Buy no. Yeah, that's like weird. There we go, guys. One very big bug that we see right now is the order book is able to get negative, quantities, which of course is incorrect. So our matching logic should do a bunch of things. Although I really thought I wrote this logic. Here is a to-do for you. I mean, there are a bunch of to-dos. One is deposit and withdrawal. And number 2, this weird ass edge case that we have missed, which is if you keep on buying no, the quantities start to become negative, which of course is incorrect. Try to do it by reading through the code base, and I'm sure AI can fix it. But try fixing this yourself, without using AI. The to-dos now, I mean, if you had to, proceed from here, number 1 would be deposits and withdrawals would be a great thing to add. So if you want to understand, crypto infrastructure, probably do that. The other thing was, there are a bunch of edge cases that are just incorrect. Some of them I remember, for example, no balance locking. If I'm sitting on the order book, my balance isn't locked, so I can just, sit with very high quantities on the order book. Number 2, no balance locking. And the thing that we saw, negative quantities for some reason, which of course is incorrect. These are just two to-dos I've written, but I'm sure there are like a bunch of other things to, do over here. Probably an admin dashboard through which admins can create new markets, things like these. Yeah, that's all I can think of right now. Hopefully you learned something new from the video. The code will be on GitHub. If you want, I can create more comprehensive issues, but there's no point of it. Just, if you do want to proceed from here, try targeting these issues yourself. I think that's all I had for this one. Hopefully you learned something new, specifically around, how predictions markets work under the hood, especially the, weird reverse logic of how their order books work is like pretty interesting and confusing. So if you understand that, kudos to you. This was one of the first projects of the first Super 30. And, I think these finance projects sort of make you code very heavily. So hopefully you learned something there. With that, I will end it. I will see you guys in the next one. Bye-bye.